Hello, a warm welcome to COPA's last safety seminar of the year. It is a huge milestone for all of us for this initiative as it's truly taken off month over month through you, our friends, our peers for joining us and viewing at home during a very unique type of year and helping to make this program so successful. Month over month, we've seen up to 1,600 of you, our members, our flying community, show up to these events on topics ranging from helicopter flying, from mountain flying, from drones to aircraft ownership. And we know we can't get to every single topic that might interest you, but we do aim to cover as much as possible, and we'll continue presenting these seminars in 2022 and 2023. There's very exciting plans underway for what that will look like. You're seeing in front of you a screen filled with 4 faces. Some may be more familiar than others. I'm Sharon Chung. I'm the Director of National Programming for COPA. I'm joined by Christine Gervais, our President and CEO, Cynthia Murphy, who heads up our aviation operations, as well as Doug Eving, who who heads up the Tannis Aircraft Products organization as well. So, Christine, let's start with you. It's great to have you here. It's been a big year for COPA under your leadership. What are some highlights as it relates to our association or the safety program for you?
So thank you, Sharon, and welcome everyone. I'm just reading all of these hellos from everybody in the chat room, like from coast to coast to coast, which is really, really nice to see. They're just pouring in. We've got like 600 people right now. They keep coming, so this is great. Yes, definitely a year of change at COPA. Again, unprecedented year. We've had to deal with COVID throughout the year. And all of the challenges that came with that, vaccine rollout, travel bans, reopenings. So it's been a very interesting year, but it has given us a chance to exploit some opportunities. And the safety seminars happens to be one of those things. I had this vision last year where I wanted COPA to be the operator of the recreational pilot. I wanted our organization to be the safety management organization for recreational pilots, so that we can meet that same standard that commercial operators experience. So I'm really happy with the safety program. I'm just going to give a quick shout out to my home airport of Smith Falls, because I know that they were hosting a viewing party today, and they were giving coffee and donuts to all of those who went and viewed it with them. So a big shout out to them. Great incentive and a great idea. I hope others follow their lead in the future. If you haven't already, I haven't heard of any other ones doing that. And more importantly, before I go into the things that we've done this year, I just want to say thank you to the whole COPA team. It's a whole new COPA team this year, we could not have done any of this without all of you. You have made these seminars a reality, and have exceeded all of my expectations for the vision that I had. I want to make a special mention to Sharon, who really led this whole initiative and put the whole program together. And she's going to continue to lead the program, and she's going to continue to evolve it, and she's going to continue to improve on it. So you deserve a huge round of applause. I can hear it across the nation from coast to coast to coast. You really deserve much of the credit for this program. So really, really appreciate everything that you did to put this together, including gathering all of the prizes and all of the speakers, and Doug Eving is now a new friend of ours, a new COPA friend. So we're very, very happy about that. Other things that we've been able to do this year is we've introduced our pass membership, and we've included our pass operations in our safety seminars, and in our COPA Flight magazine, in our eFlight news bulletin that we send out weekly. For those of you who don't get their news bulletin, you have to register for it, and you just send an email to COPA at COPA National, and we will register you for that. And we've also introduced some new scholarships that are coming in 2022. That's another big thing. So we're still going to have the ab initio scholarship. We've increased the amount that we're giving for that because we've noted that the cost of training has gone up. So we're now giving a $14,000 scholarship to an ab initio student. We've got 3 advanced scholarships of $2,500 each that are coming up next year. And we've also got 3 advanced RPAS certification scholarships also coming up next year to encourage anyone who has a basic certificate to want to get their advanced certificate so that they can work in the industry. So lots more coming up next year. I'm not going to give it all away. We're going to save something for the new year. And I'm going to pass it back to Sharon. Just welcome everyone. And I'm looking forward to following along for this seminar as well.
Fantastic. That was a great summary of an awesome year. I think many of you at home can feel the difference within COPA. We're shaking up and adding some new life to an already incredible association. And there were some really good updates there. So thank you very much, Christine, for your leadership of COPA and really just helping to redefine what general aviation looks like in Canada. Very good. And I should say we did have about over 1,800 people register for today. I don't see the numbers right now on my screen, but Christine was saying around 600 or so. So we'll see what it looks like at the end. Just so appreciative of you being with us here today, whether live or if you'll rewatch on demand or on replay later on. Now, moving on to Cynthia, your role is a new one, Director of Aviation Operations, and Christine had introduced it to really signal to our membership the focus on member relations, on the importance of specific aviation expertise to support our members. Could you provide more background on what this role does for members who might be having some issues with their medicals or having some aviation issue questions?
You're on mute.
Sorry. First time of the year. Thank you, Sharon. So my role is basically to work with any technical, safety, or regulatory matters. So if you have any questions with medicals, I can help you navigate them. I can reach out to Transport Canada to see what's going on. If you have any questions with the cars or if you have any safety issues, please feel free to reach out. That's what my job is. My job is to be here to help members, to not necessarily know everything, but to help you find the answers and research things that our members are questioning or have issues with. So that's basically the extent of it.
Fantastic. So keep an eye out in the new year as that role becomes even more prominent. Doug, Christine had said that we've become very close friends with you, almost best friends. So you've been with us for a few presentations this year. First of all, most of us are in Canada, but where are you located, and what's one takeaway that you hope our viewers get from your presentation today?
Thanks, Sharon. I always start my presentations when it's the United States by saying greetings from the Great White North, but with this crowd that probably falls a little bit differently with the Bob and Doug McKenzie crowd. But I am in west central rural Minnesota airport right now, which happens to be the manufacturing plant of Tannis Aircraft Products. And the takeaway that we really want from, which has been fortunately a good thing with COVID, is how well we can use these online webinars to get the messages out to a large amount of people. But probably more importantly, the one thing we like to go over is take a look at it, save it. You've got a video, you've got some information. You're not going to gather everything at one time. You can always go back and listen to it, talk to it about a friend, and of course, all of us are open for you contacting us. That's really my one takeaway: is you've got a book on the shelf, a video on the shelf that you can use in the future.
I love that. Learning aviation is more accessible today. So excellent. So before we get started, I have a few housekeeping notes to include. And of course, Tannis Aircraft Products is here with us today as they've they were one of the first sponsors of this program, and these programs are free because of the support of great organizations that support general aviation. So kudos to Tannis Aircraft Products, and I'll do a little mention of the other sponsors that we have from the year. And I'm sure many of you at home, I did get a few emails as well, Christine, of a few other viewing parties. So I know you're on the edge of your seats waiting for the draw. It's coming up. We won't tease you too much. Christine, in a few moments, will conduct the draw for 3 lucky annual prize winners. So this will be our first draw. And if you are new here, this will be an annual occurrence, and we will try our best to make them the pot as sweet as this year. You get an entry per attendance of our safety seminars. It's as easy as engaging with COPA and just learning. It's attending the recurrent trainings. It's attending the non-recurrent trainings, so that you're focused on just collecting as much information as possible. Following the prize announcements, Mr. Evank will then walk us through the world of aircraft preheating, and I'm sure many of you have questions as you're all here for winter flying. So we welcome any questions that you have for Mr. Evank. Just put them in the chat. There's a chat to the right side of your screen, and if you do find that it becomes a little distracting, there should be a red button where you can click it to minimize the chat and then maximize the presentation screen. If you do have any technical issues throughout the event, my recommendation, whether it's volume issue or some staggering with the content, refresh your page. It is often the internet signal that you have. If there's any really big issues, the recording will be made available in a few short days. And then following the aircraft preheating presentation, Ms. Murphy, so Cynthia here, will then begin her pilot recurrent training presentation on winter flying. It is a pilot recurrent safety seminar. Yes, you heard that right. So Cynthia will walk you through on how to record that in your logbook. And you will also receive a certificate to represent you or acknowledge your participation in today's seminar. So now we know we can't make every live event available to you based on your schedule, and some of you have been a little disappointed of not being able to make it based on whatever time zone you're in, and we've tried our best to accommodate with weekdays during the night so that it can capture both West Coast, East Coast, as well as the safety recurrent trainings on Saturday mornings where it could stretch out as long as possible. You may have seen an email from me that our seminars are now available on demand. So it's the same process as registering for this webinar through the other sessions. And just by participating in those, you can also get the recurrent training for those that do qualify for those sessions. So we heard you, and we're making it possible to learn when you want, where you want. There's a page on our website under our safety program where you can access all of the on-demand content that we have available in 2021 and then moving forward. What else is there? Moving on to the exciting topic of insurance. I mentioned earlier how promising these numbers have been to COPA, but also to our regulator and to our insurance broker. So you've likely heard me talk about an accident forgiveness insurance incentive that is available on our website. The more that you participate, there are incentives around that. So our insurance company, our regulator, Transport Canada, they're very encouraged by these numbers. It reflects a very strong safety culture here in Canada. So let's continue showing those numbers and showing up, whether you attend the live sessions or the on-demand content. With that, Christine, would you like to add anything more on the insurance side of it, or maybe some conversations you yourself have had with our friends at Transport Canada on the safety program? You're on mute.
Yeah, of course I am.
Can't be the last seminar of the year.
This is exactly. Definitely getting some fantastic feedback from Transport Canada about the quality of our seminars. They are certainly they are backing us every time that we produce a pilot recurrent training seminar. We are part of the we will become part of the Transport Canada pilot recurrent training program as well. So we're very happy to have that relationship, and so the aviation operations director does sit on all of the working groups with Transport Canada and is therefore able to hear all of the concerns that Transport Canada has when it comes to general aviation. And hopefully what we can do through these seminars is address these issues so that there are no regulations that are required. And that's the whole intent. I mean, when it comes to advocacy, regardless of what you're trying to advocate for, it all comes down to safety. If we don't want to see more things that are mandated for our aircrafts, we have to be safe. How do we be safe? Well, we attend safety seminars and we continue to learn. Having a pilot's license, whether it's a glider's permit, whether it's a student permit, whether it's a commercial, private, there's a huge responsibility that comes with that. And we want to make sure that our members live up to that standard and live up to that responsibility. So that was the whole point of these seminars. And I think that the insurance industry is as well taking note. We're certainly keeping statistics on whether these have an impact on the incident and accident rates. And if it does, then eventually the intent is to have those insurance rates come down because our members will be safer. There will be less incidents and accidents. There would be less claims, and we'll be able to drive those prices down. We're also doing the same thing for, we are aware of the concerns with the older pilots over the age of 70. I do say older, I do not say old. Over the age of 70, we are collecting that information and we are actively working with the insurance company so that they can have statistics to back up their claims or not, right? So we are advocating for you on that. So yeah, so we're doing a lot, and I'm very happy that I get to be the one who picks the name of the winners. It's great to have the fun job and to make these people happy.
Not a bad job, eh? And before we get to the draw, I was looking through the chat here. There's so many wonderful comments. Thank you so much for being here and sharing where you're coming from. I see a comment from Paul Holscher saying, "Big thanks to the COPA team. Despite the challenges of COVID, I feel more connected to COPA more than ever." And that's the magic. Thank you very much for saying that. That's what we're aiming to achieve here, to make learning easier, accessible, and to connect everyone together, even as challenging as it can be. So with that, let's move on to the exciting part of the draw. Christine, you have a COPA toque. That's correct. And of course, the thousands of names that we have could not all fit in there.
No, the toque's not big enough for everybody who attended. So I do have, yes, there is paper in here, but yeah, full disclosure, they are blank. We did use an online tool to select the winners.
We're efficient here at COPA. But we believe in pageantry as well. So over to you, Christine.
Sure. I've gone into the question and answer side of the chat room, and there are a few questions. We're going to stick to questions that relate to the seminar today. All of the questions that are about pilot medicals or licensing or that sort of thing, we're going to take note of it and we'll answer them separately, just in the interest of time, because there's going to be a lot of questions as it relates to the seminar. So just you're welcome to answer them or to ask them, but I would suggest the best way to do that would be to send your questions to avops@copanational.org, and we'll be able to answer them at a later date other than the seminar. Okay, so we're going to go with the first prize winner. The first prize is Lost Aviator Coffee Prize Pack. We've got a Garmin D2 AirWatch. We have a Sirius XM package. That's a 1 year of Pilot Pro plus 1 year of Sirius XM All Access Entertainment plus the activation fee. We have a COPA 1 year membership or a renewal for those who, well, actually, you have to be a member to win, so it's a renewal. And we have a COPA National Fly-In event registration for you for the full weekend. And we have a Aircraft Spruce $100 gift card. So the total prize value of the first prize is $2,600. So I will go drums, please. I will pretend to pull out a name from the Kopatuke. And the first winner of our first prize is, hang on here, Dave Simons from Mile Ranch, BC. And Dave has been a member since 2011. So congratulations, Dave Simons. We will be in touch with you, and we will send you your prize. So now we'll go to the second prize, which is a value of $2,400. So not too shabby there either. You've got your Garmin D2 AirWatch, your Sirius XM package, which is the 1 year of pro-life, 1 year of Sirius XM All Access Entertainment, plus the activation fee. Copa National Fly-In event registration, again for the full weekend, and an Aircraft Spruce $100 gift card. Drum roll, we're going to pick another name. You can get these Kopatuks for the Copa store. Great Christmas present, stocking stuffer. All right, number 2 goes to Walter Butler from Sherwood Park, Alberta, and he has been a member since 2012. Congratulations, Walter. All right, prize number 3, which is a value of $150, is a Copa National Fly-In event registration and a $50 coupon Copa store gift certificate, where you can get one of these Kopatuks. All right. Brad Wilcox, congratulations, Brad. And from Coburg, Ontario, who has been a member since 2017. So congratulations to all 3 winners. Thank you so much for having participated in these seminars. I don't know how many you've participated in, but I just want to thank you. We do these for you, and hopefully you're getting something out of it. And I'll pass it over to Sharon.
That's too exciting. And for those of you who may have done a collective ah in the room, no worries. There will be many prizes in 2022, specifically throughout the different seminars and, of course, the annual draw. So we'll continue working to make it as exciting as possible. There's no fix. I promise. This was a tool, very neutral. Of course, and we took all the names for our Copa members who participated. So congrats to all the winners. Before we start, just to go back to acknowledging our sponsors and thanking them, this is a free safety program. Every safety seminar is available to any pilot across Canada, any pilot, regardless of where you are, really. And we strive to provide some high quality learning. There's some strong plans ahead in the next few months to continue what we're doing, but to enhance the professionalism of the delivery of these seminars as well. So from the prizes that we offer, the tool that we use, the terrific speakers that we sign on, all of this, it really would not be possible without support from sponsors. So if you have the chance and you see their names, and you have the time to support them, support them. They're supporting general aviation, they're supporting recreational flying. So our title sponsor for this year was Garmin, and I think you saw some of the prizes in the annual prize included some Garmin watches. That's fantastic. We also have Pull Employee Benefits, Sirius XM Aviation. These two are big proponents and big supporters of Copa, of course. We have ForeFlight, and last but not least, we have Thomas Aircraft Products with us here today. So we're very lucky for those who are sponsoring and supporting us and helping to make these programs come to life. So thank you very much to all of our sponsors. And with that, I now welcome Doug to provide an overview of aircraft preheating. Thank you for being with us here today, and of course for supporting the safety program.
Thank you, Sharon. And if I can ask Sharon or Christine, I saw something about volume. Is my volume coming through okay?
Yep.
Perfect. Okay, I'm going to jump into a screen share here to go through what we call the basics of aircraft preheating, with some installation and servicing tips. Not a lot. We got to be considerate of the time also here. And as everyone mentioned, just put your questions into the chat and we'll address them either here during the seminar today, or as we have in the past, we will connect with you via email, or I've had several phone calls with folks that were on the meetings in previous presentations. So aviation safety starts with TANF preheat is kind of our tagline because it's so important to be able to fly when it's so smooth and you don't have to worry about density altitude. So of course we're a big proponent of flying in the wintertime. I was kidding with the folks in the beginning. I normally start my presentations because usually we are about the furthest north person or company, and I say greetings from the Great White North, but with this crowd that's a little bit different. So as you see here, we've got a brand new Cirrus landing on Lake Mille Lacs in central Minnesota, or one of our customers where we have our preheat system on the Erickson air crane. And this is in Canada when they're installing the high voltage power line. We play heavily in that marketplace. Just a little background information. We have two facilities. One, Blaine, Minnesota, is a suburb of the Twin Cities, and that is where our engineering, sales, a little bit of R&D admin happens. And our manufacturing plant is actually still here in Glenwood, Minnesota, west central Minnesota. That's our facility here. The name Tanis, Pete Tanis was the founder. He brought it here in the late 80s and 90s, and we've been here ever since. And most recently, July 1st of this year, I sold the Tanis aircraft preheat products to Hartzell Propeller and their heated products area. And with that acquisition now, you'll start hearing things about the Hartzell family of brands, which of course is Hartzell Propeller, that's been around for over 100 years, AWI, which is another Minnesota company, and you see the others that are on that list. So I took a snapshot of this when I walked into the airport here at Glenwood this morning, and it was -8 degrees Celsius. And that's probably the last time I'm going to say C in my presentation here. Everything else is going to be in Fahrenheit. But once you get below 20 degrees Fahrenheit or below 6-7 degrees Celsius, most of the engine manufacturers require, they say you must preheat at particular temperatures. Not all of them tell you, in fact, most of them don't tell you how long you should preheat, how warm it should go. They just say you must preheat. So we're going to try to help demystify that a bit today, and Doug knows how to push the buttons the right direction. We will go there. So first of all, let's start with why you should preheat. We do that. Most of us think, hey, so the engine starts. That's really not the major goal. The major goal is to make sure we don't cause excess damage, excess wear, and starting an aircraft engine that is made up of dissimilar metals that expand at different rates when they've totally contracted because of the environmental temperature that it's in. So we want to increase the life of the engine. We want to make sure the battery gives you all the cranking capability. When the battery is mounted forward of the firewall, our preheat system pretty much does it when it's heating the engine. But as we know, many of our aircraft's battery are now after the firewall. The ease of starting does fall into that. And of course, especially flight schools, frosting the spark plugs can really ruin your flying day because it usually eliminates it. And we are now seeing a lot of radial engines and warbirds, open cockpits. They have to have oil temps at a certain temperature prior to flying, and we're helping them doing that. Our piston engines, the cylinders have a taper to them. So again, expanding at different rates. Once the combustion process starts, everything starts heating up very quickly, but we don't get the proper oil flow. We might get pressure, but we don't get the proper oil flow through all of the journals and items that need to get the oil. So we don't want to be scoring your cylinder. Basically, we want to increase the ability for you to fly. So aviation safety does start with TANF preheat. And last and surely not least, as we just stated a little bit ago, engine manufacturers do mandate preheating at certain temperatures. So let's talk a little bit about what TANF does when we look at saying, okay, we want to develop a preheating method that really works the best, covers all of the manufacturer's recommendations, and then even going up and above that. So when we design a system, first of all, we want to see, and there's some variables in here, but number one, we design that system so that we get the cylinder head temperature about 50 degrees Fahrenheit above ambient. Now, granted, your ambient's going to be all over the place, and we'll circle back to that a little bit later in the presentation. So that's goal number one. Goal number two, we want to get the oil temp at least 40 degrees above ambient, 35 to 40 degrees. but we also don't want to see the oil temperature at 120 degrees Fahrenheit and never warmer than the cylinder. And I'm going to jump into a little bit of physics, so there's a caution here. The reason we don't want the oil to be warmer than the top of your aircraft engine is moisture, water, condensation has been intermixed with our oil once we stop flying, and it will make its way to the bottom of the sump. But that water evaporates at any temperature. Of course, when you're plugging in a preheat system or heating it up, that evaporation rate expands and goes quicker. And we talk about the wet washcloth. You leave it when it's hot and humid in the summertime, it stays wet all day. But if you leave it in your house in the wintertime when we're using firewood or other type of heating things, the delta will dry that washcloth off so quickly. So that's the physics side of it. We want to make sure with our multi-point preheat system that we get the cylinder warmer than the oil, so that even then that moisture evaporates out of the oil into your crankcase. It cannot condense on anything because that metal, your cylinder, your piston, your valves, your cams on some of the aircraft engines are not covered with oil at that time, and they really could end up being cooler than the oil, and then that moisture will condense on it. So we've designed our complete preheat system in such a way that you can leave it plugged in all the time. And I was answering a couple of the questions in the Q&A before I jumped on, because once I share my screen, I don't see the Q&A anymore. That's why we say we can leave ours plugged in all the time. There's a reasonableness factor. If you're not going to be flying for several months, then you should look at ways to preserve your aircraft engine. And depending on if you have a partially heated hangar, things like that. But ours is really the only system that do that, because you will be able to see, and the slides are a little bit further down the line here, we get everything warmer than the oil. And that is the key of what we're doing. And here's something I really want to be able to cement into your minds. We give you all this information. We're going to say, here's what you want to do, but you can test this out yourself. You can do really similar tests that we do by just taking a look. If you happen to be flying this aircraft, or if you have an engine monitor, you have cylinder head temperature and oil temperature at your disposal before you start that aircraft engine. So that is item number 2 that I wanted to leave you with. You have data that you can use to make a determination what's going to happen when I start up this aircraft engine. Now, we, of course, use data loggers that are NIST traceable. So you see the little calibration tags on all of our thermocouple wires, and we take them and put them all throughout your aircraft engine opposite of where we're heating it, and we will put it one down the oil fill tube to get one in the oil, so we get the oil temperature. Because even though I said you have that at your disposal with an engine monitor, that oil temp gauge may be someplace not necessarily right sitting where your oil temp is in the bottom of your sump. So we go out and do temperature mappings all the time with insulated engine covers, without insulated engine covers, in a partially heated hangar, in a unheated hangar like you see right here. And then we get this data back. And this is what I want to jump into to share with you what is really important. Remember, I said I wanted to see the cylinder head temperatures. That's these 4 lines here. I want to see them warmer than my oil temperature, which is this green line right here. We can do these tests any time of the year. It was 60 degrees, 65 degrees Fahrenheit. We got it up to 125. So that's our 50 to 60 degrees above ambient. And the oil temperature was 100. So we got that 35 to 40 degrees above ambient. That's our goal. Of course, what we're really looking at is how quickly can we get that done. So this was 5 o'clock. Here's 6:30. So hour and a half, we jumped up those cylinders. We got them up warmer than the oil right away because there's more mass in the oil, and that takes longer to heat. And you will see the various tests that we do here just confirms that what we're doing and how we're doing it and the different types of engines are meeting our goals. One item that you will also see, I know it's probably an eye test here. Here's our prop temperature. We actually take a thermocouple and put it on the prop too, because you'll notice when we're preheating, guess what? We're also heating that wonderful, great big spinny thing in the front of our airplane. So if you're really in cold operating climates, having a prop cover does also give you some more utility, because we are losing heat outside of that prop. Here's another aircraft, another engine, just showing you again the same thing. More realistic temperatures like you saw today. It was 18 degrees at our airport. This was 15 degrees where we started. But the reason I put this slide in here is so that you see we don't have any thermostats. We don't have any controlling devices. We make the aircraft preheat system with the amount of wattage designed based on the weight and the makeup of your engine. So we ride the ambient curve. The temperature in the hangar dropped down 5 degrees. So you're going to see that drop down, and then it's just going to ride that curve throughout that period of time. But as some people that are saying, wow, 50 to 60 degrees, that's great, but I like to fly when, now this is all Fahrenheit, but I like to fly when it's much colder than that. I need more heating than what your 50 to 60 degrees and 40 degrees above ambient will do. That is when the insulated engine cover comes into play. You can just about double your performance of the heating if you use an insulated engine cover. You'll see we got the same thing that we talked about earlier, an hour and a half to 2 hours. That's actually an hour. That one jumped up. We're at our optimum temperature. Then we added an insulated engine cover, and we got that. But it takes a lot longer period of time. So now you're talking about at least plugging it in the night before or the day before you go flying if we need that additional temperature. Here's one where you do a bunch of these tests and you get the data back, and you all of a sudden go, what in the world is happening here? Of course, we didn't have this great little line sitting here telling us that to start with. We had to figure it out. This was a flight school. They tuck in about 7 or 8 aircraft inside of a very large hangar, large hangar door. And the temperature of the cylinders was bouncing around all over the place until they closed the door. And what this really shows you, it wasn't that windy of a day. It was just showing you how effective our air-cooled baffles are on those aircraft engines that are air-cooled. So cowl plugs, another really, really important thing to use. If you're going someplace and flying and you're going to be there for an hour and a half, 2 hours sitting outside, a set of cowl plugs will get you a long ways, even if you don't have an insulated engine cover. So we wanted to show you that so you could kind of get a picture of what happens. Now we're going to make a transition to say, well, there's many different types of preheat systems, furnaces, hot air that's blown in there, sump-only preheat systems, insulated engine covers, etc. And we do all tests on all different types of those. And we had a flying club challenge us to say, well, Doug, we use a sump-only preheat system, and we have an insulated engine cover that we put over top of it the minute we're done flying. And boy, that engine, I'm sure it's all the exact same temperature. Well, we did a test for them, and what they found out was a little shocking to them. Even with that insulated engine cover in there, you see this difference of temperature. This is their oil. Here are their cylinder head temperatures. You have just set yourself up of a case where a question was asked earlier, can I leave mine plugged in all the time, or should I do it just before I fly? If you have a sump-only preheating system, you should only plug it in prior to fly, a couple hours before you're flying, because you don't want to plug it in the night before, have this happen, and then the weather closes in on you and you can't fly the next day, because now you've deposited some condensation above your oil line in your aircraft engine. If you fly it soon, you're okay. But if you don't fly for another week or two, you start going down the road of something we don't want to see. And what happens now, we took that preheat system off that exact same aircraft engine. We installed ours. Here's the oil temp. Here's the cylinder head temperatures. And yes, you see that wide swing. We just follow that ambient curve. That is really the key of what we're talking about and what we're doing with our preheat system. So what is our preheat system? If you aren't familiar with TANUS, what does it look like? We have a threaded element, a little bolt. We take either the intake tube fastener or one of the rocker cover fasteners, replace it with a heating element, one per cylinder, and then also a pad that on a 6-cylinder aircraft, you're going to have one on top of the case and one on the bottom of the case. If it's a 4-cylinder, it's just going to be on the bottom of the case because the weight of the engine is less than the need to have that amount of wattage put all the way through there. So that's our system. That kind of gives you the snapshot of it. And then the question comes, well, how do I know if my Tannis preheat system is working, or really from that case, anybody's system? How do I know if it's working? Well, I gave you a real quick one. If you have an engine monitor, you'll be able to know if that is working by looking at your CHT temperatures or your oil temperature. Or if you don't have one of those and you have our system, we have an indicator light that's telling you at least got power to your system. Doesn't tell you every element is working, but you at least know that the extension cord hasn't gotten pulled off from the other side. But here's one real quick and easy way that everybody can carry these with them, keep them in your hangar. Wherever you plug your extension cord in, buy one of these inexpensive, I think $30, $40. We're really looking at watt meters. Whatever system you're using, you should know they should list the wattage. Our 4-cylinder systems run about 240 watts plus or minus 10%, because we do everything at 115 volts and 230 volts. Our 6-cylinder system is going to run about 460 watts. So that's a feedback mechanism to you to know that that preheat system, every element is working for you. So it's very quick and very easy. Also, an ohm meter for the ones, if there's A&Ps on this line or mechanics. Real quick, easy way is to get your ohm meter, put it across the 2 flat terminals on the plug, and we list the ohm reading. Of course, wattage and ohms, you can go back into it, but 55 ohms is the right ohm reading, or on our 4-cylinder system, a little bit higher. But if you see this, now you know you have a shorted element someplace. So I said I was going to talk a little bit about installation and service. So that's the case. If you want to service it, the fuses are blown. No, you don't replace the fuses and plug it right back in. You go take your ohm meter reading. Hey, something's shorted out here. Now just disconnect. We have environmentally sealed connectors. They're Deutsch LAD connectors, TE. And you just disconnect them, plug them back in, and you can go ahead and see what your ohm meter does. Once you unplug the one that's shorted out, you'll see the ohm meter go up, and then you can go from there. Before I jump into this, I did want to talk a little bit more about a couple other things that really come into play when you're preheating. People will say, wow, you're talking about moisture and condensation, how important it is to have a multi-point and getting the top of the engine warmer than the bottom. Well, what about that moisture? Where does it all come from? Why are you talking about it? Well, when we get done flying and shut the engine off, the crankcase is usually somewhere pretty close to 180 degrees, 140, 180 degrees, and almost 90 to 100% relative humidity because of the bypass of the combustion process. That moisture all comes from the combustion process. Does not come from the environment around your aircraft, even though a little bit will. Obviously, the breather will take some in and out, but people will ask the question, well, what can I do to get that moisture out of my engine? Of course, we have a preservation kit if you're not going to fly for a long time to address that, but there's other means also. There's dehydrators out in the marketplace. We used to have one, or we have one in R&D again, but it's probably not going to see the market yet for quite a while. But getting moisture out of your aircraft engine is very, very useful, especially if you're not flying that often, because really, if you fly at least once a week, twice a week, moisture in your engine is not a big deal, because you're lubricating that whole internals of your aircraft, you're moving the moisture around. But a dehydrator does a great job of pulling that moisture out of your aircraft engine, and it's really more so for summertime flying, or if you're by the coast where you have salt water, really important to deal with on the aspect of let's get the moisture out so we don't deal with that issue. One of the things I did want to also talk about, if you can leave ours plugged in all the time, but there's a reasonableness factor. You don't have to. You can plug it in the night before, but some of us live 40, 50 miles away from the airport, and that's inconvenient. Well, we came out with a device here just September of last year called Switch-On, our preheat remote side, where it's basically we use the data side of the cellular towers to communicate with this device, to turn it on prior to flight, an hour and a half, 2 hours if you have a sump only, night before if it's ours. And we are launching that product out in Canada now. If you go to switchyon.ca or go to switchyon.com and you're in Canada, it'll remote through you. And we're using the TELUS network, so you'll see the green spots. For anybody that's on here in Saskatchewan, sorry, no coverage there. But you'll see that it doesn't have full coverage, but it's another option for you to be able to turn your preheat system on. You saw there are 2 channels on that item, so you could use one for a cabin avionics heater, one for your aircraft, maybe 2 aircrafts. You can share it with a customer of yours, but I just wanted to talk to you about that item. Now, there's many different types of preheat systems. People will say, "Wait, hey, I use a heated blower to blow a lot of hot air underneath in the cowl, and that really warms up my engine." Well, it does to the touch, but inside of it, it really doesn't. Even there's another brand of preheat system that uses a hose clamp around the base of the cylinder. And when we do a thermal imaging test on that, you'll see here's our preheat, 50 watts of heat going into each of those cylinders. Here's 100 watts of heat going into those cylinders. The air-cooled baffles do a great job of cooling everything off. We also do helicopters, fan jets, turboprops. We preheat even many things outside of the aviation industry. So you may have seen that if anybody's in the central part of Canada. That was our last STC project on that bird straight north of us here, working on the power line. And of course, we have wintertime fun. We jump into an cut open piece of our lake here in Glenwood and do what we call the polar plunge. And we invite anybody to come and join us if you feel so inclined. I'll leave my contact information up here for a bit. And again, put your questions into the Q&A and we will address them at whatever appropriate time. And I should have it back over to you, Sharon. No, not Sharon. Sharon did an escape on us, didn't she? So
she did. Sharon is actually on vacation, and she joined us this morning because she wanted to be present for the last seminar of the year, and she wanted to say hello to everybody. So I told her she can resume her vacation up until next Monday. So she has left us. Thank you so much, Doug. Very informative. I do have some questions for you, but we will answer them at the end of Cynthia's presentation. So without further ado, I didn't want to say, if you look on the right hand side of your screen, there's a chat and then there's a Q&A. If you could put your questions in the Q&A side and not the chat side, it's a lot easier for me to go and get those questions. I'm taking them out and then we'll be able to answer them. If they're in the main chat, it's difficult for me to scroll through and to find them. So if you want to go into the Q&A only section to ask your questions, that would be greatly appreciated. We will only answer questions that relate to seminar today. Any other questions will be answered via email next week at some point. Yeah, so enjoy your winter flying seminar, and I will pass it over to Cynthia now, and have a great seminar, everyone.
Hi, good morning, good afternoon, depending on where you are, everyone. So thank you for having me. My name is Cynthia Murphy, and welcome to A Pilot's Guide to Winter Flying. For some background information on myself, I've been in the aviation industry for many years. I started my career as a flight instructor at the Buttonville Airport. After that, I've attained my Transport Canada Airline Dispatcher Certificate, and I worked as a licensed dispatcher for Voyager Airways, for Air Canada Jazz, and for NAV Canada. I've also worked as an instrument procedures designer, so I have seen many different sides of aviation. And I'm excited to be presenting this pilot recurrent training program for the COPA safety program today. I'd like to thank you all for taking time today out of your weekend to refresh and your winter flying skills and maybe learn something new. So this is a recurrent training, which means it does count for your 24-month pilot recurrent training. In order to qualify, you do need to stay till the end of the presentation, the start of the Q&A, and you'll be adding these details to your logbook to track that you attended today. So you need the presentation name, the date, and the presenter, which is myself. So I'll leave that up for a little bit. Hopefully, if you need to copy it down, you'll have time. And if not, you can just let us know and we'll send it all out. Just some housekeeping items. This presentation has quite a bit of information. So just in the interest of keeping things on time, we are going to hold off on answering questions till the end of the presentation. We do have some time scheduled for questions and comments and discussion points. There's also a planned break at the approximate halfway point. So with that all being said, let's get on with the presentation. So winter flying in Canada. To many, this country means winter and the frozen north. Ice, snow, cold, and winds. Every day there is some new challenge of weather to deal with. Mountain conditions, wind and snow, polar fronts, lake effect, icing, and more. Like us pilots, airplanes don't like the cold. They especially don't like the ice. Brakes can freeze, carburetors and pitot-static systems can be blocked by ice. Ingesting ice can be a problem in fuel-injected systems and even for turbines. Piston engines are particularly prone to accelerated aging when cold starts are attempted. And to make it all that much more complicated, it's no fun to pre-flight your airplane at -10 degrees. Many pilots hang up their keys in the winter months, but there's no reason not to enjoy the benefits that winter flying can bring. Yes, I said benefits. Winter air is smoother, less subject to bumpy thermals, and denser, which improves piston performance to levels you cannot expect on a hot summer day. And with winter's cold air and low humidity, visibility can be spectacular. So today we will look at a variety of topics to help you with your winter flying. We'll cover preparing for flight, cold weather operation, effects of cold on the aircraft, winter weather, icing, and winter survival. Preparing for flight in the winter involves a lot more than just preheating and doing the walk around. We'll take a look at all the factors you need to consider when flying in Canada in the winter. This includes being prepared for the possibility of an off-airport landing, including the suitability of your clothing, the contents of your emergency kit, and your own fitness to fly. Most pilots are familiar with winter conditions in their particular area. However, often a distance of just a few miles may change the environment enough to present new problems to an inexperienced pilot. There are certain precautions that are significant to winter flying. Flight planning during winter months will require special knowledge in order to protect the aircraft as well as the pilot. Extra precautions should be used. Following roads in the winter is not a bad idea. Often roads that are well traveled during summer months will be abandoned in the winter. To be forced down far from civilization may create a serious problem of survival. With today's extensive highway systems, most flights in small aircrafts would only be extended by a few minutes if a well-traveled route were followed. Even the vehicles on the road can give valuable information. You may see cars and trucks coming towards you with fresh snow adhering to the front of the vehicles. In most cases, you might as well start making a 180-degree turn due to reduced visibility ahead. You, the pilot, have complete responsibility for the go, no-go decision based on the best information available. Do not let compulsion take the place of good judgment. The first thing to address for winter flying is the readiness of the pilot and passengers. Have you gone through your I'm safe checklist? Plan to wear weather-appropriate clothing? Checked the weather and planned a route? This is I'm safe, a standard checklist for your own readiness as a pilot. Are you feeling well and fit? Are you taking any medications that may affect your fitness to fly? Are you free from abnormal stress factors such as personal problems, time constraints, etc.? When did you last have a drink or two? Are you well rested? Are you well fed and feeling healthy? Winter flying brings with it the risks of off-airport landings. How well prepared are you for the possible walk in the cold and/or the snow? Those lightweight boots you wore to the airport in your nice warm car may not be so suitable for even a short trek to the farmhouse in the distance if you happen to put down in a farm field. Now think about what happens if you land on a frozen lake miles from the nearest buildings. You and your passengers need to be dressed appropriately for the weather conditions on the route and not just for the drive to the airport. Winter weather conditions vary considerably in cold climates. In the most remote sections of the world, weather reporting stations are generally few and far between, and reliance must be placed on pilot reports. However, don't be lured into adverse weather by a good pilot report. Winter weather is often very changeable. One pilot may give a good report, and 5 or 10 minutes later, VFR may not be possible. Near large bodies of waters, you may have to deal with highly localized lake effect snow squalls that don't show up in forecasts. Keep in mind the effects of local terrain. Even elevation changes of a few hundred feet can trigger localized weather. In particular, mountain flying and bad weather don't mix. Set yourself some limits and stick to them. Setting up a winter-friendly route can be very important. If your trip is over highly populated areas, the risk of finding yourself in a winter survival situation can be minimal. However, most of Canada is wilderness, and it's not a bad idea to plan a route that keeps you close to a better chance for recovery in the event of a forced landing. Staying close to highways is a good strategy, and as we mentioned briefly before, vehicles traveling on those roads can offer good visual cues regarding what may lie ahead. For example, if you notice the vehicles headed towards you have lights on in broad daylight, it may be a clue that you are headed to an area of poor visibility. Now we'll look at preparing the airplane. For baffling and winter covers, be sure the winterizing of your engine follows manufacturer recommendations. Does your engine require a winter kit, such as air intake baffles to keep cylinder head temperatures within limits? Some engines require a baffle on the oil cooler air intake to keep oil temperatures within limits. Are these properly installed? When looking at oil, many engines require different grades of oil depending on the outside air temperature that you may be experiencing in your region. The crankcase breather deserves special consideration in cold weather preparation. A number of engine failures have resulted from a frozen crankcase breather line, which caused pressure to build up, sometimes blowing the oil filler cap off or rupturing a case seal, which caused the loss of the oil supply. The water, which causes the breather line freezing, is a natural byproduct of heating and cooling of engine parts. When the crankcase vapor cools, it condenses in the breather line, subsequently freezing it closed. Special care is recommended during the pre-flight to assure that the breather system is free of ice. If a modification of the system is necessary, be certain that it is an approved change so as to eliminate a possible fire hazard. For hoses, hose clamps, hydraulic fittings, and seals, an important phase of cold weather preparation is inspection of all hoses, flexible tubing, and seals for deterioration. After replacing all doubtful components, be certain that all clamps and fittings are properly torqued to the manufacturer's specifications for cold weather. Many aircraft are equipped with cabin heater shrouds, which enclose the muffler or the portions of the exhaust system. It is imperative that a thorough inspection of the heater system be made to eliminate the possibility of carbon monoxide entering the cabin or cockpit area. Each year, accident investigations reveal that carbon monoxide has been a probable cause in accidents that have occurred in cold weather operations. Because of contraction and expansion caused by temperature changes, control cables should be checked and properly adjusted to compensate for the temperature changes encountered. Wet cell batteries require some special consideration during cold weather. It is recommended that they be kept fully charged or removed from the aircraft when parked outside to prevent loss of power caused by cold temperatures and the possibility of freezing. Some engine preheater manufacturers offer heated shrouds or blankets for the battery that is connected along with the engine preheater. Warm batteries deliver better cranking power than cold ones. During thawing conditions, mud and slush can be thrown into wheel wells during taxiing and takeoff. If frozen during flight, this mud and slush could create landing gear problems. The practice of recycling the gear after takeoff in this condition should be used as an emergency procedure only. The safest method is to avoid these conditions with retractable gear aircraft. It is recommended that wheel pans installed on fixed gear aircraft be removed in the winter to prevent the possibility of frozen substances locking to the wheels or brakes. Let's take a look at this video on pre-flight procedures in the winter.
The winter months can bring beautifully smooth, dense air that truly makes flying enjoyable. Unfortunately, the same cool temperatures that make the air smooth can also present various challenges to pilots of all general aviation aircraft. Extra care must be taken to ensure that the aircraft is safe to fly, and this usually means spending extra time outside in the elements. So dress appropriately for the cold temperatures. Keeping your aircraft properly maintained is the first step to ensuring the aircraft is ready to fly. Have your AME specifically check the cabin heating system before the cold weather sets in. Any cracks in the system can allow carbon monoxide to enter the cabin, and since carbon monoxide cannot be smelled, it's a serious threat to the safety of your flight. Also be sure to keep an up-to-date carbon monoxide detector in the aircraft. Although always a critical component of a safe flight, a walk around is especially important when the weather hits, particularly if the aircraft is left outside or in an unheated hangar. Frost, ice, and snow can easily make their way into places where they shouldn't be. The engine breather tube is often not checked as part of a standard visual inspection. In fact, many pilots are unable to show where it's located on their aircraft. Talk to your AME about how to properly inspect the breather tube and any other aircraft-specific equipment that you're not familiar with. Be careful to inspect all the critical surfaces, especially the hinges and cables on the control surfaces, to ensure they have full and complete uninhibited movement. Remember that the CAR's mandate that all critical surfaces are to be free of contaminants. Even a thin layer of frost is not allowed and must be removed prior to flight. The braking system is especially prone to malfunction while operating in colder temperatures. The wheel pans, although nice to look at, are difficult to inspect underneath and can easily become filled with snow and ice. The fuel system of a typical light aircraft is usually fairly simple. However, it's also prone to failure if not understood and inspected properly. Pay extra attention to the fuel caps, ensuring that they're not bent or damaged, allowing water and other contaminants to enter the fuel tanks. If they're vented caps, make sure they're not blocked by ice that could prevent them from being able to do their job in the event the fuel vent becomes blocked. If there's water in the tanks, be extra vigilant to ensure it's completely removed. Even a small amount of water entering the fuel line and freezing can completely cut off the engine's fuel supply. Finally, a cold-soaked engine is not fit to be started. Any engine that has been exposed to temperatures below -7 degrees Celsius, including the wind chill factor, should be thoroughly preheated. Consult your POH for specific recommendations from your aircraft manufacturer. Preheating will ease the starting process, but it also helps to prevent unnecessary wear and damage to the engine. If the engine is started without being properly preheated, the oil can congeal, preventing proper flow throughout the engine. If a heated hangar is not available, an electric low-voltage preheat system is the next best option. A low-voltage system that heats both the oil sump as well as the engine cylinders, along with a thick engine cover or blanket, can adequately heat the engine to proper pre-start temperatures. Although this method takes a long time to be effective, if you plan ahead and plug the aircraft in the night before your flight, it will ensure the airplane is ready to start when you arrive. One last option is to use an external blower-type engine heater. This, however, is the most abused method of preheat, as the engine is often only superficially heated. Be careful not to heat just the cylinders. The heat should be directed to the engine's sump and lines as well as the cylinders. A superficial application of preheat can result in engine damage. It may be enough to get the engine started, but it will not decongeal oil in the sump or lines, and a lack of lubrication may result, which can cause a complete engine failure shortly after the application of a high power setting. Above all, don't be in a rush to get airborne. Take your time to do things right and ensure your aircraft is truly airworthy. And that way, you'll be better able to enjoy the smooth, dense air of the winter months.
Okay, so let's review the video key points. Although Lycoming's advice is that any start below -7 degrees is a cold start and should not be attempted without a thorough preheat, it is advisable to preheat anytime the outside air temperature is 0 degrees or colder. By now, we all know that leaving even a thin coat of frost on wings, tail, and control surfaces can have fatal results. That doesn't mean it's okay not to clean the other areas such as the fuselage and cabin roof. Snow and ice that dislodges from these areas can damage the tail. On the last landing, slush and snow may have found their way into openings around the ailerons, elevator, rudder, and wheels. This material may have frozen in the meantime with predictable results. Be sure every control surface control surface moves freely and easily, and that wheels and brakes are free of ice. Removing wheel pants for the winter not only eliminates a great ice catcher, it makes inspections easier as well. The oil breather tube mentioned in the video is another gotcha. Ice can accumulate in the tube because moisture that may accumulate in the engine is eliminated through the breather tube. Do you know where yours is and what to look for? Pulling the prop through a couple of turns to break up the oil is a controversial move. It is not recommended by Lycoming because there will be little oil in the cylinders at rest and none will be pulled in because the oil system isn't activated by this action. It does more harm than good. That being said, radial engines, where oil pools in the lower cylinders, might benefit from a couple of turns of the prop. De-icing. During winter weather, frost and snow often accumulate on wings, elevators, and other surfaces when an aircraft is parked outside on the ramp. Any unremoved frost or snow will disrupt airflow over the wings and substantially alter flight characteristics. Increased stall speeds, longer takeoff rolls, or an inability to fly at all may be the result. Even a passing snow shower can foul surfaces enough to make flight inadvisable. When faced with airframe and wing contamination, you have two choices: go home or spend some extra time during the pre-flight completely removing frost and snow from the aircraft. The easiest and best way to prevent contamination is to park the aircraft in a hangar. In the highly regulated airline world, the rule is simple. An aircraft can only depart when it's clean. No snow, frost, or ice on any part of the aircraft. GA pilots should use the same winter operations principle. The Canadian aviation regulations prohibit persons from conducting or attempting to conduct a takeoff in an aircraft that has frost, ice, or snow adhering to any of its critical surfaces, such as wings and propellers. Therefore, if the pilot in command cannot confirm that the aircraft is clean, a takeoff must not be attempted until it can be confirmed that the aircraft is free of frozen contaminants. This is called the clean aircraft concept. If the aircraft is snow-covered, consider using soft bristle brooms or small snow brushes. While effective, they can scratch paint, so use care. Clean towels or shop rags will also remove snow without scratching the paint. Don't forget that your plexiglass window will not tolerate any kind of ice scraper, and even soft bristle brushes may cause scratches. This is where a bit of rubbing alcohol in a spray bottle can be very useful. The bad news is that underneath the snow, there may be a layer of ice that also needs to be removed. Removing frost and ice is trickier than loose snow, but just as critical. The best tool is a heated hanger and an hour to spare. When melting the frost and ice, make sure the water does not penetrate control surface hinges where it might refreeze and cause problems. Let's take a look at this video on de-icing considerations.
There's no such thing as an insignificant amount of ice. Frost, ice, or snow on the leading edge and upper surfaces of a wing with only the thickness of medium sandpaper can reduce lift by as much as 30% and increase drag by 40%. This will severely impact the controllability of the aircraft during two of the most critical phases of flight, takeoff and initial climb. In addition, the added weight of the contamination can be enough to put the aircraft over its maximum gross weight, which will further reduce the aircraft's ability to climb. The clean aircraft concept was developed by Transport Canada as a tool to increase and promote safety at all levels of aviation. The CARs prohibit anyone from attempting to take off in an aircraft that has any contamination on its critical surfaces. And it's not enough to assume the aircraft is clean. The pilot in command must confirm it is, and then recheck if there's any doubt as to the state of the critical surfaces. A critical surface is considered to be the wings, control surfaces, rotors, propellers, horizontal stabilizers, vertical stabilizers, or any other stabilizing surface on an aircraft. And in the case of an aircraft that has rear-mounted engines, the top of the fuselage. Storing your aircraft in a hangar is one of the best ways to prevent contamination from collecting. Remember to complete your walk-around and have the aircraft completely ready to start up before taking it out of the hangar. Depending on the ambient air conditions, it is possible for frost to form on the wings in just a matter of minutes, so departing as quickly as possible is necessary. Wing covers are another effective and relatively inexpensive method of preventing wing contamination. Like other forms of de-icing, there are pros and cons. While inexpensive, they can be difficult to install or remove, particularly on a windy day. The pilot must be extra cautious not to damage the aircraft during this process. And remember, although the wings have been covered, other areas of the aircraft have been left exposed and may still require the use of another method of de-icing. Manual methods of snow and ice removal, although a lot of work, can be quite effective at removing the contamination from critical surfaces. Brooms and brushes are some of the most common devices used. However, be aware that significant damage can be done to the aircraft while utilizing a manual method of contamination removal. Take great care in using this method, particularly around pitot tubes, static ports, and the windscreen. Perhaps the most well-known method of de-icing is using a glycol-based spray. For general aviation aircraft, the Type 1 de-icing fluid is used most often. Type 1 fluid is orange in color and is a hot mixture of glycol and water. Because it is applied hot, it's effective at removing much of the contamination from an aircraft. It's also a good idea to complete your walk-around and engine run-up before being de-iced. There's no sense in paying to have an aircraft de-iced that's not airworthy. And your mechanic will thank you too. It's not nice to work on an aircraft covered in de-icing fluid. It's recommended that the pilot and command monitor the application of Type 1 fluid to ensure that it's not directly sprayed on engine openings, windows, pitot tubes, and static ports. And if the de-icing fluid does get onto those areas, it's the PIC's job to ensure that they're cleaned and that the aircraft is still airworthy. And if you aren't able to depart soon after your aircraft is de-iced, remember to check the critical surfaces once again before takeoff. Depending on the atmospheric conditions, frost or other contamination can form quickly and you may not be able to see it from the cockpit. Keep in mind that there's no such thing as just a little bit of ice. So allow lots of extra time to ensure the aircraft is clean and ready for a safe flight.
Airframe de-icing systems may be available at some airports. Glycol or Type 1 solution is the most expensive solution for GA pilots, and it is generally only available at select FBOs. Other more sophisticated de-icing materials are available, but the expense, weight, and requirement for sophisticated application equipment means only scheduled carriers will benefit from their use. And we have another quick video on frost and flight.
Frost on the wing can't hurt, right? Wrong. Nothing will disrupt the aerodynamic flow of air more readily than the irregular surface created by hoar frost or snow crust. Yet every year there's evidence that some pilots choose to flirt with this serious hazard. Frost occurs during the fall and early spring during clear nights with light or no wind movement. Some pilots may underestimate the effects of frost on wings, but even a little frost can raise the stall speed of an aircraft. Studies show that roughness, as little as only 0.01% of the wing thickness, will adversely affect lift and the angle of attack at which stall occurs. On a large aircraft, roughness of 1/32 of an inch along the leading edge of the wing can reduce the lift as much as 20%. So on a light aircraft, even the smallest amounts of roughness will ruin the smooth laminar airflow over the surface of the wing. The rough surface of the frost disrupts the airflow, creating circulating air currents or eddies. So when the air passes over the upper surface, it won't adhere firmly to the curvature. Add in any factors such as a short airstrip, soft ground, or a tailwind that may force you into a premature liftoff or climb out, and you're in trouble. And although the aircraft may be able to fly in ground effect, when the nose is raised to climb away, a stall can result in an angle of attack considerably less than normal. Light aircraft need all the aerodynamic assistance the manufacturer intended. So before flying, use a broom, scraper, squeegee, or de-icing fluid from aircraft services to remove all traces of frost and snow. The bottom line is, if your wings are covered with frost or ice and you can't de-ice, you can't fly. So on those crisp, frosty mornings, the solution can simply be found with a little patience. If you can't tow your aircraft into a heated hangar, turn it into the sun and go have a coffee, as the frost will soon melt away. Frost.
So de-icing is not as simple as spraying fluid on an airplane and heading out. An assortment of details must be considered by the pilot and command and coordinated with de-icing personnel. These include areas of where not to spray on the aircraft, such as engine inlets and windows. Which way the aircraft should be pointed prior to application, which is into the wind, and where the aircraft fluid application should begin, which is often different for de-icing and anti-icing sprays. Because of the complexity of proper de-icing, it's essential that a briefing be conducted between the pilot and de-icer prior to the beginning of fluid application. So, what can we use on our own GA aircraft? Polypropylene antifreeze is pink in color and is available at RV, automotive, or marine stores. Placed in a small garden sprayer, it works quite well, especially if the sprayer is heated to room temperature. A note of caution though, composite aircraft owners should test it in an inconspicuous area first, as there have been reports of staining. Automotive windshield de-icer in a spray can is inexpensive and can be purchased at gas stations and department stores. Do not use it on aircraft windshields or windows. It's the easiest to carry, and unless the airframe is heavily iced, will yield several applications. Rubbing alcohol, sold in relatively small quantities in drugstores and supermarkets, can work in a pinch using a spray bottle with a hand pump. With the exception of glycol, these products are inexpensive to purchase and should be used liberally. Remember, you want the aircraft to become airborne. And now we'll look at snow-covered airports. Winter flying often means you will be parking, taxiing, taking off, and/or landing on contaminated surfaces. The surface is considered to be contaminated whenever standing water, ice, snow, slush, or frost in any form is present. Operating on slippery surfaces adds a whole new dimension of risk. It's important to plan ahead and be aware of the conditions of your departure and arrival airports. The simplest thing is to call your airports ahead of time and ask about the conditions at the time of your flight. If you are planning on flying to a larger airport where runway conditions are published via NOTAM, are you aware of the new format and how to read it? Runway surface conditions used to be contained within a NOTAM-J, but now will be in an RSC NOTAM. So why did the format change? The International Civil Aviation Organization has developed a new globally harmonized methodology for runway condition assessment and reporting called the Global Reporting Format, or GRF. The implementation date for GRF in Canada was August 12, 2021. The Global Reporting Format and associated developments are important safety initiatives intended to mitigate the hazards associated with operating on wet and contaminated runways and the associated risks of runway excursions. The GRF safety initiative resulted from the efforts of various civil aviation authorities, major aircraft manufacturers, and many others, including pilots associations and airports. Hazards and risks associated with aircraft operations on wet or contaminated runways, as well as numerous accidents that have occurred during these conditions, are well known and have been thoroughly documented. Runway overruns have been on the Transportation Safety Board's watch list since 2010. The TSB has stated, snow, rain, ice affect runway surface conditions. Pilots need timely and accurate information about runway surface conditions in all seasons to calculate the distance their aircraft needs to land safely. Canadian implementation will meet the intent and important safety elements of the GRF, but will also provide some enhancements. One of the main differences from the ICAO format is the ability to report 2 contaminants. Reporting 2 contaminants will allow pilots and flight dispatchers to accurately determine the maximum allowable takeoff weight or distance, since the limiting contaminant is not the same for all airplanes. It also harmonizes the reporting in North America, since the United States Field Condition NOTAM also lists 2 contaminants. The final product for Canada is the Runway Surface Condition NOTAM. The photo in the slide is of a Boeing 737-700 runway overrun accident at Chicago Midway Airport, which occurred in December of 2005. This accident was a catalyst for the review of reporting runway surface conditions and the ultimate creation of the global reporting format. The format of the RSC NOTAM will look different. RSC NOTAMs will use the standard field headers. Some runways will now be reported in thirds rather than as an average across the full length. The RSC NOTAM also includes the new runway condition code. With the new GRF, standardized common terminology and phraseology for the description of runway surface conditions can be used by aerodrome operator and inspection personnel, air traffic controllers, aircraft operators, and flight crew. This is a significant safety enhancement. A maximum of 2 surface descriptions can be reported, either by third or for the full runway length. A runway or runway third is only reported dry in certain circumstances. As the percentage of snow no longer needs to add up to 100%, as the percentage of coverage no longer needs to add up to 100%, dry is no longer reported if other surface descriptions are present, and the location of some of the information within the NOTAM has moved. So thinking in thirds, the RSC NOTAM gives airport operators the option of reporting the runway conditions either by full length or in thirds. Reporting the runway condition information in thirds with the associated runway condition codes provides useful information for pilots, and we will cover what these runway condition codes are in just a few slides. This format helps to improve situational pilot awareness by identifying where the contaminants that affect airplane performance and directional control are located on the runway. So how will reporting the runway condition in thirds improve situational awareness and safety? As you can see in the photo, the 2 dashed blue lines overlaid on the photo help to show that the contaminants which affect airplane braking performance and directional control are located in the first 2/3 of this runway. When reporting by thirds, this information is conveyed to flight crews by both the runway condition codes as well as the runway surface descriptions for each third of the runway. The runway condition is reported in the direction of flight by dividing the runway into 3 portions. The values are then reported in the direction of flight, providing touchdown, midpoint, and rollout observations. Both RSC and CRFI can be reported by thirds. The RSC NOTAM introduces the concept of the runway condition code. This is the runway condition assessment matrix, or RCAM. A preliminary value from 0 to 6 is based on the observed condition is determined, with 0 being the most slippery and 6 being dry. The assessment criteria section of the RCAM consists of a runway surface description and the runway condition code. The runway surface description in each category are linked to the corresponding runway condition codes based on their effect on airplane braking performance. The runway surface description column lists the contaminants as well as temperature and depth and the runway surface conditions if the runway is dry, wet, or slippery when wet. These runway surface descriptions are directly correlated to aircraft landing performance and are listed in order of slipperiness. Runway condition codes represent the runway condition description based on defined terms and increments. In the event that the full width of the runway is not cleared, the runway condition code will be determined based on contaminants present in the cleared portion of the runway, typically the center 100 feet. Finally, the last column is the control and braking assessment criteria section of the RCAM, which provides criteria to be used by the airport operator to determine if the runway condition code accurately reflects the slipperiness of the runway. Control and braking assessment criteria include vehicle control and deceleration observations and pilot braking action reports. Pilots should understand how the airport operator determines the runway condition codes which appear in the RSC NOTAM. Familiarity with this process is needed to understand how and why the published runway condition report may be downgraded or upgraded. The airport operator determines a preliminary code using the RCAM based on the runway surface description. For example, based on type and depth of contaminant and outside air temperature, on the runway condition when the runway is dry, wet, or slippery when wet. After the preliminary condition codes have been assigned, the airport operator should determine that the preliminary condition code accurately reflects the runway conditions. Through this determination, which should consider the Canadian Runway Friction Index if available, vehicle deceleration or directional control observation, pilot reports, local knowledge, and/or other information, the preliminary runway condition codes will then be confirmed, downgraded, or upgraded. If the preliminary runway condition code accurately represents the runway condition, the preliminary code will be confirmed and the final runway condition codes may be disseminated. If it is determined that the runway condition report is not accurate, The operator can downgrade or upgrade the runway condition report, and that will be noted in the RSC NOTAM. So how will these runway condition codes apply to general aviation? The advisory circular provides guidance on how to use them. This table shows the recommended landing distance factors to apply based on the runway condition code. The landing distance factor includes a 15% safety margin and is applied to the unfactored distance you can find in your pilot operating handbook. For example, if the current runway condition code is a 4, you would find your unfactored landing distance from the POH and multiply it by 2.8 for a reciprocating engine aircraft to find the recommended distance required for landing. Taking a look at the Canadian Runway Friction Index. Airports that are maintained to ICAO standards measure the friction index of contaminated runway surface, and the published results is the CRFI. This is expressed on a scale from 0, with no traction at all, to 1, meaning excellent traction. You can use the table published in the AIM and the CFS to judge the suitability of the surface for your plane and skill level. An example of the CRFI diagram appears in this slide. In the example shown, the wind is 40 degrees off the runway at 20 knots. We can see a headwind component of 15 knots and a crosswind component of 13 knots. As you can see from the CRFI line below, the minimum recommended CRFI for takeoff or landing in these conditions would be 0.35. Following the runway surface condition reports in an RSC NOTAM is a section for the Canadian Runway Friction Index readings. Like the runway condition codes, some runways will be reported in thirds and others will be reported over the average length of the runway. However, it should be noted that the CRFI reporting is an element of the runway surface condition reporting. The CRFI section will appear in the RSC NOTAM regardless of whether an observation was taken or not. In cases where a CRFI observation is not available, the term NR or not reported will be stated. The CRFI is deemed as additional non-global reporting format or takeoff and landing performance assessment information as evidenced by the header which appears in the RSC NOTAM. Concluding the RSC NOTAM are 3 separate remark sections for taxiway and apron conditions and any other general remarks. Some aerodromes will report runways in thirds and include runway condition codes, and others will not. While all aerodromes will use the RSC NOTAM format, whether its runways are reported in thirds or by full length is determined by the airport operator. This decision will be made in consultation with air operators and in consideration of the types of aircraft using the aerodrome. In general, pilots can expect longer runways to be reported in thirds and shorter runways to report by full runway length. Whatever approach is taken, aerodrome operators are encouraged to remain consistent within a season. As shown in this example, when a runway is reported in thirds, it's important to keep in mind the direction of use. The 3 runway segments are reported accordingly in the NOTAM and verbally in the order the aircraft will travel across the runway surface, from the nearest to the furthest segment. You can expect to hear some new phraseology from air traffic control, flight service specialists, or from an ATIS message. The decision to report the runway in thirds or by full length is made by the airport operator in consultation with air operators. To minimize confusion, the reporting type will need to be consistent throughout the season. Note that the runway condition codes are only reported if the runway surface conditions are reported by runway thirds. Airports can publish RSC NOTAMs by thirds, by full length, or a combination of some runways in thirds and some runways full length. There are 3 distinct sections of the RSC NOTAM. The start of the NOTAM contains the header, and it is followed by the RSC section. The RSC section shows all runways with their runway surface conditions. You can see in this example that runways 07 and 25 are reported in thirds, and runway 1432 is reported full length. Because runways 07 and 25 are reported in thirds, they have associated runway condition codes, while runway 1432 does not. The CRFI section, where the CRFI readings for all runways are displayed, and you can note the additional non-GRFI heading on that section. In the final section, you have the remarks, where you will find the taxiway apron information and general remarks. There'll be some differences. So let's look at some of the ways the RSC NOTAM will differ from the NOTAM-J. This RSC NOTAM example shows both reporting by thirds and reporting by full runway length. The new format also includes a more spaced out format for easier reading. Up to 2 runway surface conditions are allowed to be reported. Dry will only be reported when 100% dry. As a result, the total does not have to add to 100%. You can tell when 2 conditions are reported for certain sections by the word "and." Fractions will be used instead of decimals for depth measurement, and full text will be used more often. More information on the RSC NOTAMs can be found in the materials listed for references. They are the Advisory Circular 700-057, Section 8 of the Canadian NOTAM Operating Procedures, as well as AIC 24/21. So tips for winter airport operating conditions. At most small airports, you are on your own. You can call ahead and ask the airport manager about conditions before you go flying. But remember that you will be getting someone else's advisory opinion, but you as the PIC are fully responsible for determining the safety of your flight. Here are a few more tips. Walk the runways and taxiways to inspect them for traction and snow depth before you take your plane out there, and check for PIREPs. Run-ups on slippery surfaces are not advisable. Look for some bare ground first. Keep taxi speeds even lower than normal, and use ailerons and elevator positions suitable for wind when taxiing, even in tricycle gear airplanes. Be careful of snowbanks when taxiing. It's easy to catch a wing on something that wasn't there a few hours earlier. Don't ride the brakes. This will heat up the gear, allowing snow and slush to melt into the mechanism, which will later freeze back into ice, rendering the brakes unusable, or worse, lock them up. Keep an eye out for snow removal vehicles and equipment. Treat arrivals at airports with unknown conditions as precautionary landings. Inspect from low level before making the decision to land. Let's take a look at this video on airports and ice and snow-covered aerodromes.
If you operate an aircraft in the winter months, there's the possibility of having to taxi, take off, or land on a contaminated surface. A surface is considered contaminated whenever standing water, ice, snow, slush, or frost of any form is present. Contaminated surface operation requires additional pilot skill and attention and is not something to take lightly. Being informed and planning ahead is the first step to staying safe in aviation. Be careful to choose the type of airport you wish to operate from. An aerodrome that adheres to ICAO standards actively clears the surfaces of the majority of contamination and provides a CRFI, or Canadian Runway Friction Index, may be your best option. The CRFI found in the aerodrome's NOTAM, along with the crosswind component chart found in your CFS, can be a valuable resource in your decision-making process. The proper use of this information will give you a good idea of how controllable the aircraft will be during the takeoff run or landing roll. If operating out of an uncontrolled aerodrome, you're more or less on your own. If at all possible, you should walk the taxiways and runways prior to departure. This will give you an idea of what type of surface contamination there is, as well as the depth of any snow. For the arrival aerodrome, call the aerodrome operator prior to departure to get a runway advisory. Although a useful aid to your decision-making, remember that this is an advisory only, and you, as pilot in command, still make the ultimate decision to land or not. And remember to check for PIREPs, as they can be a great tool in your decision-making process. Engine run-ups can pose a particular challenge if the surface conditions are slippery. If the wheels are on ice or packed snow, as power is increased to perform the run-up, the aircraft can begin to creep forward, potentially into another aircraft or obstacle. It's advisable to perform your run-up while on bare pavement, especially at night, when the aircraft creep can be more difficult to detect. When taxiing on a contaminated surface, take your time. If the wind is strong, your aircraft may want to weathercock into the wind. The problem is often compounded by speed and can lead to the aircraft departing the taxiway. Remember to always use proper aileron and elevator control inputs as outlined in your aircraft flight manual or POH. These control inputs will aid in the ground controllability of your aircraft, even at lower speeds. Snowbanks can pose additional hazards for pilots of high-wing and low-wing aircraft alike. Don't forget that the wings stick out a significant distance from where you are, so keep your head moving and be aware of the position of your aircraft in relation to the sides of the taxiway and runway. Snow may seem soft, but it can cause considerable damage to an aircraft in motion. Remember, never ride the brakes while taxiing, especially in cold weather. Any snow or slush caught on the braking system will melt from the heat generated by brake usage. It can then refreeze once the aircraft is airborne, causing the wheels to become stuck in place. The unsuspecting pilot is now in a situation of having little or no control of the aircraft during the landing roll. Be particularly careful when arriving at an unfamiliar airdrome. In some cases, the snow is removed from the runway and piled up just to the side of the runway surface. This usually isn't a problem if you land on the center line. However, if you choose to land to the side of the center line for operational reasons, or if you drift right or left, the snowbanks can present a considerable hazard. Finally, be aware of snow removal vehicles. If you want to depart, it's best to wait until they finish clearing the snow. It'll probably make it easier for you anyway. If you're inbound to an uncontrolled airdrome that's being cleared, you'll need to wait until the snow removal vehicles leave the runway. You may consider diverting to another airport, but make sure you have enough fuel to make it there with at least the proper car's minimum reserves. If you're unable to wait for the runway to be cleared, make a precautionary low-level pass over the runway to alert the snow removal vehicles to your intention of landing. In some cases, they'll be able to leave the runway area and allow you to land. Winter flying can be a lot of fun, but remember to plan ahead. Take your time, and if in doubt about your ability to handle the ground conditions, save the flying for another day.
So now let's take a look at cold weather operations, and we do have another video on engine operations in cold weather.
A bonus of cold weather operation is that your aircraft performance is significantly increased. Effective horsepower is greater, the air is often smooth, and most importantly, fuel costs go down. It's every pilot's dream come true. However, operating a reciprocating engine in colder weather does require extra care and planning to prevent unnecessary wear and tear on the engine and to maintain the safety of the flight. Talk to your AME to ensure that your engine has the proper viscosity of oil for the temperature in which you'll be operating. All oils are affected by temperature and tend to become thicker as the temperature gets colder. Aside from difficulty starting, using an incorrect viscosity oil can prevent proper lubrication of the internal engine components. Depending on your aircraft, you may need to install engine baffles or winter kits once the temperature drops. Consult your aircraft manual for instructions on how and when to install them. Remember that fuel does not readily vaporize at cold temperatures, so be careful not to overprime and flood your engine. Starting your aircraft in cold weather can sometimes be difficult and frustrating. Always allow the recommended cool down periods for your starter motor to make sure it isn't damaged during a difficult start. Once the engine is started, keep the idle at 1,000 RPM. This is especially important during cold weather to prevent lead fouling of the spark plugs. Pay particular attention to the oil pressure gauge just after startup. For many light singles, you should see pressure within 30 to 60 seconds. However, every aircraft will be different in how the gauge responds. So learn the characteristics of the gauge for your aircraft and watch for any deviations from the norm. Once the engine has been sufficiently warmed up, complete a thorough run-up. Pay particular attention to the engine gauges and ensure that everything is in the green. Listen to your aircraft. Does it sound right? You can tell a lot from the sound of the engine and can hear something that isn't quite right before it can be seen on basic engine instrumentation. If you're flying with a carbureted engine, check for carb ice prior to entering the runway for takeoff. It could have accumulated during the low power setting used during taxiing. Throttle use should be smooth and precise. Avoid large, quick variations of power. As a general rule, movement from idle to full power positions should take around 3 seconds. This is gentle on the engine and is efficient for a standard takeoff roll. When airborne, keep the oil temperature in the recommended range. Pilots are aware of the dangers of overheating an engine. However, running an engine too cool is a significant danger as well. Low temperatures may not permit the moisture that collects in the oil to vaporize. The oil can then become contaminated and possibly leading to engine damage. Engines are designed to be run in a lean state. Once you've reached your cruising altitude, leaning should be standard operating procedure. Consult your POH for specific procedures recommended by the manufacturer. As you approach the end of the cruise portion of your flight, remember to avoid sudden cooling of the engine. Engine damage due to fast, low, or no power letdowns can result in cracked cylinder heads and more. Reduce your power gradually, but maintain some power throughout the descent. Keep your descent speed at high cruise or less, and a descent rate of 1,000 feet per minute or less. During a prolonged descent with lower power settings, it's advisable to clear the engine in accordance with the procedure outlined in your POH. The momentary smooth application of increased power will help to ensure that full power is available if required. And if your aircraft has carb heat, don't forget to use it whenever the power setting is reduced to below 75%. And remember to either use full hot or full cold carb heat unless instructed otherwise in your aircraft's POH. Winter flying provides a great aviation experience, but it's important to understand the additional stresses that cold weather can place on your engine. Treat your engine with care, and you can expect a trouble-free winter season.
So let's review the key points from the video. Be sure the engine is set up for cold weather, engine baffles installed, proper oil grade for cold conditions. Avoid overpriming and flooding during difficult starts. Minimum idle of 1,000 RPM to allow for proper warming, and keep an eye on oil pressure and temperature during warm-up. Listen for unusual noises during warm-up. Don't start the run-up until temperatures are in the green, and check for carb ice before takeoff. No sudden power changes. Keep it smooth and avoid sudden power decrease to avoid shock cooling. Use cowl flaps or power settings to keep temperatures in recommended range, and clear the engine every 500 feet during low power descents. Okay, so thanks for that, everyone. We're going to take a 5-minute break. I currently have 1:12 p.m. Eastern Time, so we will reconvene at 1:17, and I will see you then. Hello, everyone. Welcome back. Just before we continue on with the presentation, I have received a couple of questions regarding the CRFI and whether it is going to be included or not. It is no longer a requirement for the RSC NOTAM. If it is reported, it will be included in the CRFI section. It is not required as the RCAM replaces the requirement for it. So I hope that makes sense for everyone. If it doesn't, please just let me know, and I'll do a little bit more research and make sure that, that I can answer any questions that we have about it. So if that's good, we'll just continue on. So look at cruising in the winter. And we have another video for navigating in the winter months.
Visual flight during the winter months presents different challenges to aviation than are found during the summer. Snow-covered ground and the low-lying sun make navigation difficult for any pilot, even in a familiar geographical area. What would normally be a simple, easily navigated flight during the summer can become complicated by the lack of distinct navigational reference points in the winter. Lakes, power lines, and roads are key navigational features used by VFR pilots to help determine current location and heading. Once they're snow-covered, they can be difficult to spot and may look completely different. Frozen snow-covered lakes may appear like open fields, and snow-covered country roads may be easily confused with power line corridors. Crossing large snow-covered lakes can present a significant challenge to VFR pilots. The featureless terrain of the lake can blend with an overcast sky and lead to the horizon disappearing and disorientation setting in. If you do need to cross a large snow-covered lake, it's a good idea to stick to the shoreline and reduce the chances of experiencing a whiteout condition. In the digital age, it's tempting to overutilize technology at the expense of proper pre-flight planning. For many pilots, GPS has become a tool of choice. Like many tools, it can either be used or abused. Over-reliance on GPS is dangerous and significantly decreases the pilot's situational awareness. Proper pre-flight planning is required anytime you're departing on a flight. Go back to the basics you were taught during your initial flight training. Dead reckoning, the skill of using time, distance, and heading to arrive at a waypoint, is accurate and reliable even when all other technology fails. If you do have a GPS aboard, use it to back up and confirm what you already know, not the other way around. When navigating, visually read map to ground and prove to yourself that you are where you think you are. Picking a spot on the ground and then trying to locate it on the map can lead to improperly determining your position and the possibility of straying off track, sometimes by many miles. If you do get lost, remember the 5 C's. Climb as high as you can for better ground visibility. Conserve. Slow the aircraft down to endurance speed to save fuel. Circle. Figure out where you are instead of flying blindly ahead. Confess to yourself that you're lost and get help from ATC. Comply. If ATC gives you instructions, follow them. They're there to help. Get help before you get into trouble. Asking for help may be a hit to your ego, but running out of fuel or entering restricted or controlled airspace is sure to be a lot worse. If operating around large bodies of water, remember that lake effect snow can appear quickly. Although the name streamer may sound like a small band of snow, the reality is that streamers can be quite large and intense, causing severely reduced visibility and the possibility of airframe icing. Finally, don't forget about the reduced daylight hours. Every year, pilots are caught unprepared. If you're not night rated, give yourself a significant margin. Plan to be on the ground at least 1 hour before sunset. Although it may be legal to fly up to 30 minutes past civil twilight, the visual landing cues that you're used to are not the same at twilight. Without being properly trained, you risk damaging your aircraft or worse, injuring yourself and your passengers. If you do find yourself running late and unable to make it to your chosen destination airport, divert as early as you can and make sure that you advise ATC or the responsible person that you left your flight notification with as soon as practical. Diverting to a different airport than you had planned is a much better decision than trying to fly at night without a night rating. Flying in the winter can be a great experience, but be sure to leave yourself lots of options. Perform thorough pre-flight planning, and if possible, carry extra fuel. Remember the adage, time to spare, go by air. Flying, particularly in the winter, isn't a race. Take your time and put safety first.
So let's recap the key points of the video. Things look different in winter. Snow cover can hide key navigation cues, such as lakes, power lines, and roads. Snow-covered roads can look like power line corridors, and small lakes can look like farm fields. Large snow-covered lakes may look like whiteouts, where the snow-covered ice sheet blends with the overcast skies. Following the shorelines has its advantages. Overcast reduces contrast and ground features become indistinct, and it's easy to become disoriented or get lost. Don't forget the lost procedures, the 5 C's. Climb for better visibility and overview of terrain. Conserve, slow down and conserve fuel. Circle, figure out where you are before proceeding. Confess, get help from ATC, and comply with ATC instructions. Get help before you get into trouble. Winter weather hazards. Before the lakes become ice covered, lake effect snow streamers and squalls are something to watch for, especially downwind of bodies of waters. Days are shorter in the winter. Keep sunset times in mind when planning your day. When you see bad weather ahead, or even if nightfall is sneaking up on you earlier than you thought, the proper time to divert to a safer destination is the moment you think of the possibility. Don't make a hazardous situation worse by waiting too long to correct it. Whiteouts. Whiteouts is one of the unique hazards of winter flying. The term is used to describe winter visibility where it becomes impossible to distinguish between the horizon and the ground due to snowfall, blowing snow, or lack of contrast between the ground and the sky, rendering the horizon invisible. Height perception is also affected, and more than one pilot has flown into the ground while thinking they still had plenty of clearance. Whiteouts also described a severe reduction in visual range caused by snowfall and/or blowing snow. And another video on whiteouts.
It's common to think of whiteouts as loss of all visibility due to blowing snow. For example, helicopters can create their own local zone of whiteout caused by downwash in a hover. Keeping hover time to a minimum will alleviate this situation. Yet ironically, loss of visual contact can occur in clear air when a featureless expanse of snow-covered landscape blends into the horizon. There are many visual clues in the landscape to assist in discerning objects and judging distances. Shadows, glare, contrast in color, and clarity in distant objects are all used when flying in visual flight conditions. But a flat, featureless terrain, such as a lake covered in snow, in combination with a low ceiling or diffused light, can remove these clues. These conditions can lure pilots into relying on some inadequate visual references, like a dark line in the distance, while paying little or no attention to the cockpit instruments. The horizon starts to blend in with the terrain. Disorientation sets in, height perception is lost, and a whiteout has occurred. Conditions that look good enough for flying visually suddenly require instruments and requires quick reaction. Whenever you encounter whiteout conditions or even have a suspicion of them, immediately climb if at a low altitude. Maintain airspeed, level off, and turn towards an area where sharp terrain features exist, and as much as possible, use your instruments to cross-check your turn. Don't try to fly out of the whiteout area by using some vague external reference. If you do need to fly over large frozen lakes, track from island to island or keep the shoreline in sight and go the long way round. Unless you've had some instrument training, flying VFR over large expanses of snow-covered areas should be avoided whenever possible. A winter whiteout situation can sneak up on an unsuspecting pilot and represent a serious hazard to winter VFR flight. All you need to do is be aware and prepared, and you'll arrive at your destination safely.
Airframe icing. We have looked at the need to clean your plane completely of snow and ice before you fly. Now we will take a look at what happens when you accumulate ice in flight. Ice in flight is bad news. It destroys the smooth flow of air, increasing drag while decreasing the ability of the airfoil to create lift. The actual weight of ice on the airplane is insignificant when compared to the airflow disruption it causes. As power is added to compensate for the additional drag and the nose is lifted to maintain altitude, the angle of attack is increased, allowing the underside of the wings and fuselage to accumulate additional ice. Ice accumulates on every exposed frontal surface of the airplane, not just on the wings, propeller, and windshield, but also on the antennas, vents, intakes, and cowlings. It builds in flight where no heat or boots can reach it. It can cause antennas to vibrate so severely that they break. In moderate to severe conditions, a light aircraft can become so iced up that continued flight is impossible. The airplane may stall at much higher speeds and lower angles of attack than normal. It can roll or pitch uncontrollably, and recovery might be impossible. Ice can also cause engine stoppage by either icing up the carburetor or, in the case of a fuel-injected engine, blocking the engine's air source. According to AOPA statistics, icing played a role in 12% of all weather-related accidents during the 10-year period between 1990 and 2000. Of these icing incidents, more than half were attributed to induction, carburetor, or air intake ice. Very few GA aircraft are ever tested with icing contamination in flight. So once you start to see ice on your airframe, you become a test pilot. This is not recommended. Airframe ice is associated with cold temperatures plus moisture in the air. Although we usually associate ice with cloud, it is possible to see ice buildup in clear or hazy looking air. Structural ice is the stuff that sticks to the outside of the airplane. It is described as clear, rime, or mixed. Rime ice has a rough, milky white appearance and generally follows the contours of the surface. Much of it can be removed by de-icing systems or prevented by anti-ice. Clear or glaze ice is sometimes clear and smooth, but usually contains some air pockets that result in a lumpy, translucent appearance. The larger the accretion, the less glaze ice conforms to the shape of the wing. The shape is often characterized by the presence of upper and lower horns. Clear ice is denser, harder, and more transparent than rime ice, and is generally hard to break. Mixed ice is a combination of rime and clear ice. Although the weight of the ice accumulation can be a factor in the fate of the aircraft, the effects of ice on aerodynamics of flight surfaces are far more important and deadly. Ice can distort the flow of air over the wing and significantly increase drag. This not only diminishes the wing's maximum lift capability, but may adversely affect the handling characteristics of the airplane as well. Wind tunnel and flight tests have shown that frost, snow, and ice accumulations on the leading edge or upper surface of the wing, no thicker or rougher than a piece of coarse sandpaper, can reduce lift by 30% and increase drag up to 40%. Large accretions can reduce lift even more and increase drag by 80% or more. Ice can form on aircraft surfaces at +2 degrees Celsius or colder when liquid water is present. I'm sure that number is surprising. Why do we say +2 degrees rather than 0? As air passes over a wing, the pressure above the wing drops. As the pressure drops, so does the temperature. This is also what happens in the venturi of a carburetor. So that +2 degree air quickly becomes freezing air as your airframe passes through it. Although it is fairly easy to predict where the large areas of icing potential exist, the accurate prediction of specific icing areas and altitudes poses more of a quandary. Mountains, bodies of waters, wind, temperature, moisture, and atmospheric pressure all play ever-changing roles in weather making. In GA, we often think that VFR pilots will not be too concerned about icing because they never penetrate cloud, where the biggest risk occurs. While this is true, there are also big risks for VFR pilots that are associated with wet precipitation, rain, and freezing rain. Freezing rain and drizzle are the ultimate enemy that can drastically roughen large surface areas or distort airfoil shapes and make flight extremely dangerous or impossible in a matter of a few minutes. Freezing rain occurs when precipitation from warmer air aloft falls through a temperature inversion into below freezing air underneath. Large droplets may impact and freeze on the airframe. Along a cold front, the cold air plows under the warm air, lifting it more rapidly and resulting in the formation of moist cumulus clouds. Along a warm front, the warmer air tends to slide over the colder air, forming stratus clouds conducive to icing. As you approach the front, the clouds quickly build and the clear air between the layers rapidly disappears. Exposure to frontal conditions can be minimized by choosing a route that penetrates the front perpendicular to the frontal line. Smart ice flying begins on the ground. For VFR operations, with the exceptions of freezing rain, freezing drizzle, and carburetor icing, staying clear of clouds by a safe margin solves the icing problem. For pilots choosing to go IFR, it becomes more complicated, and that is deep enough of a subject to warrant a seminar all of its own. Immediate is the word of the day. When you encounter ice, especially as a VFR pilot, the best time to take action is right now. And the best action to take is a 180-degree turn to get out of the situation. Let's take a look at this short video on avoiding airframe icing.
When it comes to flying, planes and ice don't mix. Freezing rain occurs most often in fall and spring. It can occur at any altitude, and it's the most dangerous type of precipitation to aviation safety. Even planes equipped with anti-icing equipment are not meant to handle continuous icing. Any buildup of ice on an aircraft destroys the smooth aerodynamic airflow, affecting its performance. Add to this the weight of the ice, and you soon have an aircraft that can't maintain airspeed, even with maximum power. Avoiding ice starts on the ground. Before you go, check the weather for possible icing on takeoff, landing, and en route. Request any recent pilot weather reports or PIREPs from the nearest flight service station, and if possible, plan your route around known icing. Aviation regulations require that all snow, ice, or frost must be removed before flying. Don't assume that loose snow will blow off in flight. Besides, there might be some ice hiding underneath. If you're caught in potential icing conditions, anticipate it and get out as soon as possible. Ice can build up rapidly. Don't fly at altitudes where icing is forecast, and if encountered, do something about it at the first sign. Don't wait. Start to work your way out immediately, either by changing altitude, turning back towards good weather, or getting down as quickly as possible, or a combination of all three. Ice accumulation degrades stability and increases stall speed, so fly your approach with extra power and airspeed. And file a PIREP as soon as possible, either in the air or on the ground. Actual weather reports from pilots provide the most reliable information for forecasters and other pilots. Pilots know that no ice is good advice. Avoid ice conditions at all times. Remember, it's better to be on the ground wishing you're in the air than being in the air wishing you weren't.
Effects of airframe ice. Ice on the wings and tail changes the aerodynamics of the airplane. When ice accumulates on the wing, you can expect the need to increase the angle of attack to compensate for the loss of lift from the wings. This will, of course, be accompanied by a loss of airspeed and the loss of climb performance. Beyond a certain point, you will not be able to maintain level flight. Tail stall becomes a greater risk when the airflow over the tail is changed or disrupted. The big risk here is that adding flaps when the tail is iced may suddenly stall the tail with disastrous results. This is especially dangerous when flying low and slow in the approach to land. Thus, a simple rule: if you suspect the presence of ice on the tail, or even the possibility of ice on the tail, do not use flaps. If you do add flaps and the airplane's handling changes for the worse, or if buffeting occurs, put the flaps back to where they were. Induction ice is a big contributor to accidents. There are two kinds of induction system icing: carburetor icing, which affects engines with carburetors, and air intake blockage, which affects both carbureted and fuel-injected air engines. Induction icing accidents top the charts as the #1 cause of icing accidents, comprising a whopping 52%. Unless preventative or corrective measures are taken, carburetor icing can cause complete power failure. In a normally aspirated engine, the carburation process can lower the temperature of the incoming air as much as 60 degrees Fahrenheit. If the moisture content is high enough, ice will form on the throttle plate and the venturi, gradually shutting off the supply of air to the engine. Even a small amount of carburetor ice will result in a power loss, indicated by reduced RPM with a fixed pitch propeller and a loss of manifold pressure with a constant speed propeller, and may make the engine run rough. At the first indication of carburetor ice, apply full carburetor heat and leave it on. The engine may run rough as the ice melts and it goes through, but it will smooth out again. When the engine runs smoothly, turn off the heat. If you shut off the carburetor heat prematurely, the engine will build more ice and probably quit because of air starvation. The engine RPM should return to its original power setting. If the RPM drops again, fly with the carb heat on. Do not use partial heat. With carburetor heat on, the hot air is less dense, so the mixture becomes richer, and as a result, the RPM will drop a bit further. Lean the mixture and most of the RPM loss should return. If you don't lean, fuel consumption increases. A number of fuel exhaustion accidents have resulted from miscalculations. If carburetor heat is used for landing and you decide to go around, advance the throttle smoothly, then remove the carb heat. This will ensure all available power for takeoff. Fuel-injected engines have no carburetor and therefore no carburetor ice problem. However, when conditions are favorable for structural ice, fuel-injected engines can lose power and even fail if the air filter and intake passages are blocked by ice. This can also occur in planes with carburetors. At the first sign of power loss, activate the alternate induction air door or doors. When these doors open, intake air routes through them, bypassing the ice-blocked normal induction air pathway. Many alternate induction air systems activate automatically. These designed use spring-loaded doors. Suction in an ice-blocked air intake draws these alternate air doors open. Some older fuel-injected airplanes have alternate air doors that must be manually opened. Knobs or levers have to be physically moved to the open position in order for alternate air to reach the engine. Check the POH of your aircraft to find out how and when to use this system. Preparing for the worst, winter survival. So, suppose the worst has happened, which is what we all plan for, right? How can we best play the cards we are dealt? First, did you dress appropriately for the weather on the route as part of your pre-flight plan? Let's take a look at this video on dressing for survival.
Are you prepared if you have to make a forced landing? If not, you better think again before setting off. And this is especially important during these colder months. Being prepared starts off with filing a flight plan and making sure that your emergency locating transmitter is operational. Because in the event of an emergency, being found quickly by search and rescue forces will increase your chances of survival. Being prepared also means making sure that you're dressed for the conditions that prevail on the ground, en route, and at the destination. Street clothes may be adequate for on board, but remember, it can be cold out there when stranded. Lack of suitable clothing can take its toll in the race against time, especially in rain or snow. And even getting stuck at the end of a runway can mean a long, cold walk back if not dressed properly, and this includes what you wear on your feet. An essential part of a safe flight is having an emergency kit on board. This includes extra clothing, matches, flashlights, emergency food, a first aid kit, blankets, and sleeping bags. Onboard survival equipment is not only mandated by regulations, but can mean the difference between survival or not. If you do end up making an unscheduled landing, hypothermia can be a real threat. If you start to shiver, you need to take steps to warm up immediately. If your clothes are wet, put dry ones on. Start a fire and make a temporary shelter. Remember, even with a flight plan and a transmitting ELT, high winds, blowing snow, or a winter storm can delay a rescue and force you to stay out in the elements longer than you might expect. Survival is something you plan for in advance when everything else is going right. The key is to be prepared, and if you are, any unplanned stops will be much more comfortable in the short term, and your chance of survival that much better in the end.
So, either you had to land off airport as a result of being trapped by weather or other considerations, or worse, you've crashed. In either case, unless you know that civilization and help is a short walk away, preferably in sight, then you need to have a plan for survival. After a crash landing, it is best to exit the aircraft as soon as possible. Take time to analyze the situation and help others. Take care of any injuries first. Stay away from the aircraft until all gasoline fumes are gone. Sit down and think. Keep in mind that survival is 80% mental, 10% equipment, and 10% skills. Since the mental factors are the number one problem, establish a goal to conquer. Don't have give-up-itis or a do-nothing attitude. Don't run off without taking time to think out each problem. The enemies of survival. The number one enemy is yourself. Number 2 is injuries. Number 3 is temperature. And number 4 is disease. The best tool for survival is your own mind. In most cases, the best strategy is to stay with the airplane. If you filed a flight plan and/or were able to make a mayday call, if you have a working ELT or some other way to communicate, rescuers will know to look for the airplane and not for a lone soul trekking through the woods. The airplane, even if wrecked, can be a great resource for shelter, fuel, and fuel for fires. With the advent of search and rescue, radios, emergency locator transmitters, and more lately GPS, the advice is to stay with the aircraft. Why? Because when search and rescue starts looking for people, it goes to the last known point, then follows the proposed track. Although they're really looking for people inside the airplane, they have long since learned that the aircraft is easier to see than people. Thus, the search tends to concentrate on that area between the last known point and the proposed destination. This video offers tips for post-crash survival in the winter.
It's part of every pilot's primary training, a forced landing without engine power. But while pilots are trained on nailing that emergency landing, what happens after you put the checklist aside? How well prepared are you to survive in the wilderness, in winter, waiting for rescue to arrive? Surviving the initial crash or forced landing in the backcountry is challenging enough. Now the downed pilot and passengers have to survive in adverse conditions while awaiting rescue. Being prepared and having a plan can make all the difference for survival. And it starts with being dressed for the environment you're flying in. In winter, make sure that you have a warm Arctic-style parka, boots, warm hat, and winter gloves. Ask yourself before you get in the aircraft, can I survive for a few days with what I have with me, in the middle of the terrain over which I'm flying? If the answer is no, then rethink your equipment list. Right after the forced landing, the priority will be to move away from the aircraft in case of fire. Only return to the wreckage when you're absolutely sure it's safe to retrieve the survival kit and emergency supplies. The next priority is to treat any life-threatening injuries, dressing open cuts, ensuring proper breathing, stabilizing broken bones, and keeping warm to avoid shock. Beyond having a complete first aid kit, being prepared with first aid training is extremely valuable in dealing with this task. Next, ensure that others know that you need help. Were you able to transmit a mayday or select code 7700 on your transponder before your forced landing? Is your ELT activated and is it working? Don't assume that it activated on impact. Manually turn the switch on. Is anybody aware of your whereabouts through a flight plan or flight itinerary? If you answered positively to these questions, chances are that help will soon be on its way, weather permitting. If you have a personal satellite messenger or PLB activated, is your aircraft radio operational? VHF radio signals are effective only in line of sight. However, even with a handheld radio, you may be able to raise an airliner flying 5 miles above. It's unlikely that a mobile phone will get a signal out in a remote area, but some phones have a digital compass and can provide your GPS position, which could be useful. Now is the time to use the stop plan. Sit down. Think. Don't panic. What was the last town you saw? Was there a road? When is your flight plan closing? Observe. Observe your surroundings and listen. Do you hear road traffic? Snowmobiles? Plan. When you're thinking clearly, you can make a plan to survive. If there's more than one able body available, divide the work between yourselves and get busy. Circumstances will dictate what the first task should be. The best course of action should be to light a fire as soon as possible. A campfire is a source of light and heat, both necessary for the well-being of the survivors. Equally as important, you should be ready to create a signal with lots of smoke should you hear an aircraft in the distance. In deteriorating weather, your priority should be to find or build a temporary shelter. In the short term, you could wrap yourself in a survival blanket or tarp. Anything that will offer some protection from the wind and precipitation will do. The goal is to stay warm and dry to prevent hypothermia. The aircraft wreckage might be useful as a wind barrier, but first check for stability and spilled fuel dangers. A fire should be built on the downwind side of the shelter. Use dead wood, like a fallen tree limb. Gather plenty of firewood before dark because you will go through a lot of it during the night. If the snow cover is thin, scrape it off to build the fire over bare ground. Otherwise, use stones or align logs on top of the snow to create a platform to build on. Never build your fire under a snow-covered tree or overhang. The heat will rise, melt the snow, and put your fire out. How successful you'll be at lighting a fire can depend on the contents of your survival kit. Storm-proof matches, lighters, magnesium blocks, and flares could all work. Your first aid kit might possibly contain items that could serve as substitute for tinder or fire starter. A small quantity of fuel from the aircraft will help in getting the fire started. Your aircraft contains a battery, which, if not damaged during the landing, is a source of spark and is effective in igniting dry kindling or fuel. Just make sure that your ELT has an independent power source before you disconnect the battery and use it to start a fire. The time spent finding dry kindling and firewood is well worth it. Dry deadwood provides more heat after igniting, but to create lots of smoke for a fire signal, use live evergreen branches. If you're not fully confident that you could actually start a fire in a survival situation, practice fire starting techniques or take a survival course. If you downed over rugged terrain, or if the weather's closed in, it could be some time before help arrives. This means you need to build a more permanent shelter. Erect it at a short distance, preferably within view of the wreckage. Remember, that's what the search party is looking for. A tarp draped over a rope tied between two trees over a bed of evergreen boughs as a ground cover will offer adequate protection for 1 or 2 people. For a group of 3 or 4, or in the absence of a tarp, a lean-to structure built from chopped trees, covered with layers of evergreen boughs, will make a suitable shelter against wind and falling snow. Parts could also be stripped from the wreckage and used as building materials. Make your presence known. Smoke, lots of it, draws attention. If there's an open area nearby, such as a frozen lake, build a fire. Better yet, 3 fires forming a triangle, as this is recognized as a distress signal. Smoke can be produced by adding evergreen boughs or leaves to the fire. Have a large supply on hand to quickly place on the fire should an aircraft be seen or heard. Engine oil, tires, or other parts scavenged from the aircraft will create a thick pillar of black smoke, making it more noticeable than just a campfire alone. Ground-to-air signals, such as a V or an X or SOS, can be used by forming the letters out of branches, stones, or brightly colored or contrasting material. The symbols should be at least 8 feet across. A fabric panel of brilliant fluorescent color staked to the ground is very useful to attract the attention of the searchers. They'll be looking for anything out of the ordinary, and their eye will be drawn to any unnatural feature on the ground. A downed aircraft has the best chances of being spotted if portions of the wings or tail are brightly painted. Keep the aircraft clear of snow or brush. A signaling mirror can be an effective way of getting spotted during daytime in the sunshine. As a substitute, you could use a piece of metal or side window from the aircraft, foil, or any other reflective object. Flares should be used only when you're quite confident that they'll be seen. During the hours of darkness, chemical glow sticks, flashlights, headlamps, strobes, or even camera flashes can be used. An important task is to stay hydrated. Find some water. It's possible to survive a few days without water, but under stress, people should actually drink more water than they normally do. 2 to 4 liters a day is recommended. Often in cold temperatures, people neglect to drink because they do not feel overheated, yet you still lose fluids through breathing and perspiration. Finding drinkable water is therefore essential for survival. Snow might be your only source of water, but resist the temptation to eat it as it will lower your core temperature. Always melt it first. If you're unsure that the water you have found is safe to drink, treat it first. If a suitable container is available, you could boil it for 10 minutes, plus 1 minute for each 300 meters of elevation. A water filter may not work as well in freezing temperatures. Otherwise, treat it with water purification tablets. In most survival situations, since rescue can be expected reasonably quickly, food is not a top priority. A person can actually survive for a few weeks without any. But in the short term, food items that include simple sugars will help fight hypothermia by activating the metabolism. High energy bars, cereal bars, and trail mix will do. Remember that food also is important in keeping up people's spirits. Next, settle down and conserve your energy. If you end up spending the night in the wilderness, don't expect to get much sleep, if any. If you're missing and people are alerted to that fact, somebody will be looking for you. So keep your spirits up. Regulations require that any aircraft operating where rescue may be more difficult because of remoteness or inaccessibility should have survival equipment on board. The aircraft survival kit should include a means to provide first aid, building a shelter, making a fire, signaling, and purifying water, and be sufficient for the survival of each person on board for a minimum of 72 hours. Smart pilots equip themselves with a personal survival kit that they carry in their pockets or in a survival vest. The survival gear is not always retrievable from the wreckage, and you can find yourself in a survival situation with only what you have on your person. You certainly hope not to have to put these skills to practice in a real emergency, but being prepared is essential. Wearing proper clothing and having the appropriate gear, including a survival and first aid kit, a variety of signaling devices, including flares and smoke signals, is half the battle. But having the knowledge of survival techniques is the key to surviving in adverse conditions. Take a survival course. Always plan ahead and be prepared for the worst. It could save your life and the lives of your passengers.
So in conclusion, flying in the winter offers the best airplane performance, spectacular scenery, and the visibility to enjoy it. With a bit of planning and the right attitude, it can be an enjoyable way to spend a winter day. So now I'd like to open up for questions, comments. If you have any winter tips or tricks, we'll have a little discussion time now. And
Thanks so.
Welcome back, Christine.
Yes, thanks so much, Cynthia. Very, very informative. It makes you think twice before you head out flying your airplane in the winter, especially someone like me who hasn't flown in the winter for a very long time. So this was a very, very good refresher for me. We did have quite a few questions in the chat for Doug. So I will, he's taken note of them all, and he's going to answer them all right now. And then what we'll do is I'll ask, there's a couple of people who have raised their hands. I'll go to 3 members to ask questions, and then I'll ask Cynthia 3 more questions, and then the rest, unfortunately, I'm very mindful of the time. It's almost 2 o'clock Eastern time. Some of you have been hanging on for 2.5 hours. We still have 751 people with us, which is phenomenal. I'm mindful of the time, so I have taken note of every single question that's been asked. We will post the answers to your questions along with the video on our website, so your questions will be answered. If not today, they will get answered in the next week or so. All right, go ahead, Doug.
All right, thanks. So I tried paying attention to all the questions coming in, and kudos to the people. There were a lot of them in there. So I'm going to run through them, try to mesh a couple together. One that was a common theme when we talked about condensation, saw several pilots state, well, when I land and park the aircraft inside the hangar, I take the oil fill cap open and let that moisture exhaust out of the engine. And there was questions on whether we recommend that. So the Pat company answer is always leave your aircraft in airworthiness conditions or flag it in such a way if it's not. Because if that oil cap is removed, it's not an airworthiness condition. But with that being said, yes, that will exhaust a lot of the moisture. Once you land, you will get probably 50% of the moisture out of that aircraft because your engine is much warmer. I mean, and people were chastising me for being Fahrenheit versus Celsius. I'll switch that next time. But you're looking at 50 degrees C oil, and your ambient is going to be much less than that in the wintertime. So you're going to get rid of a lot of that. One question was about TANUS. Is it permanently mounted? Yes, it's an STC system permanently mounted on the aircraft. So it would be installed as an STC in the States, and I can't speak to Canada. That requires the 337 or the STC paperwork that comes with it. But you can also install it as a minor mod. We did the STC for outside of North America. People talked about and asked about, hey, I have a sump only, or do you recommend sump only? Is there concerns with using a sump only, and especially on a Lycoming, some corrosion on the cam? Our pad answer is, with the sump only system, only use it hour or two before flight and make sure you fly, because that's really important. Yes, we have seen moisture condense on rocker covers, top of valves, top of pistons, and on the cams with the use of a sump only. There were questions about amperage. I talked about wattage. Our 4-cylinder system draws 2 amps. 6-cylinder system draws 4 amps. Can you use it along with your battery tender? Absolutely. Can you use it along with our cabin avionics heater or a cabin avionics heater? Ours is 500 watts, or again, 4 amps, so easily. But many people go to your big box retail store and buy a heater there. A lot of times there's 1500 watts, so that's going to be 10 amps. You can't really bring those two together. The question was, can I install this? Do I have to be inside of a hangar? No, you do not have to. You can install a TANA system if you're outside. You just need to remember there's a pad element that needs to have a curing process in there. So it's going to take at least a day. It's done by moisture, so you can be able to do that. Our preheat remote switching on devices, Canadian price, $249, includes the first year of service, which is with TELUS, or $499 for the 4-channel unit. The TANA systems, $1,200 US for the 6-cylinder system, $820 US for the 4-cylinder. There was a bunch of questions about the Rotax engines. Yes, we do have a Rotax kit. Yes, it is important to have that because they are very cold-blooded per se. Even the electronic ignition ones, they have a remote oil sump, so you don't have as much issue with the condensation. That answers the Rotax. Let's see what else I have. There was a conversation talking about wind chill because, Lycoming goes into their manual and says when the wind chill is X. A piece of metal doesn't know the difference between wind chill temperature and ambient temperature, other than you will cool off that. If you have wind blowing through your cowl, you'll cool off that engine quicker. So that's why when we talk about temperatures, Lycoming says you must preheat when it's -6 or -7 degrees Celsius or lower. We've seen benefits when the temperature drops 10 degrees C or lower. We've seen benefits in using our preheat system for that. I believe I just screamed through all of them as quickly as I could there, unless there's some other ones that pop up there, Christine.
Okay, thank you so much. I'm just trying to find my window again. Too many things open on my. There we go. So some of you have had asked if we can put the slide up again for how to log this recurrent training seminar. So there you go, right there. Cynthia has put it back up again. I'll read a couple of questions that came up for Cynthia. One of them, she did answer a little bit, but we'll just go into maybe a little bit more detail about the NOTAM format change and the reason why the CRFI hasn't shown up in any of the NOTAMs. There was a question either in the Ottawa or in the Edmonton area. Did you want to just add a little bit more to that, Cynthia?
Yeah, I guess so. It's not necessarily required for part of the new format. It did say that it was supposed to have a not reported note if they didn't report it. I just really quickly ran through a couple of locations. I actually found a NOTAM for a runway condition report in Whitecourt that did show actually a CRFI reading. So I just believe that it's not required as part of the new format. It is an additional piece of information that airport operators can use to incorporate into their evaluation of the runway conditions, but it's not required. I can't tell you why it's not putting the note saying that it's not reported, but it is not required as part of the new format.
Okay, thank you, Cynthia. Have a question from Sylvie Beaulieu. In flight, is frame icing possible outside clouds?
So typically, I would say no. In order for icing to form, you need visible moisture and temperatures below zero. So if the air is clear, then you're not really seeing visible moisture. If you're flying through rain or freezing rain, definitely. If you're flying through cloud, obviously. But I don't see a scenario where in clear air, airframe icing could occur.
Okay, thank you. I think there were a couple of questions about partial carb heat. There was also a couple of questions about cycling constant speed props at very low temperatures on long flights. We don't have the answers to that, but as I mentioned, we will have the questions and answers on our website along with the seminar when we post it. So Sharon usually sends you a certificate after the seminar. There'll be a link to where it's going to be, so have no fear. I did ask someone who had raised their hands to speak, but I can't see whether or not you have accepted. Might not have been there anymore. It was Glenn. Glenn, are you with us? Nope. Okay, I will go to William. William, are you still with us? Also not there. Okay, Danielle Fortin. No. All right. Well, then I guess I'll go through a couple more if no one speaks up. We've got Horst Romani and Michael Meeks. Horst or Michael Meeks. Horst Romani or Michael Meeks. If you're still with us and you'd like to ask your questions, I just allowed you to be a speaker. Nope. All right, we've got Ian. People are dropping like flies. So I guess we will end it there. Thank you so much, Doug, for everything that you did for us this year. Oh yes, you have one comment?
Did, you know, it was 2 pages, so I flipped over to the second page and I did see 2 of them that I missed. And so just give me a quick one. People ask about oil cooler, preheating an oil cooler. If your oil cooler is obviously forward of the firewall, a lot of times it will get enough preheat if you have an insulated engine cover around it. But yes, we do, especially for the bigger aircraft engines, we do have oil cooler heating pads that you can add to it. Another person asked about actually, I think it's a Russian rotary engine. We do make kits for many radial engines and various other ones. So the M14P, yes, we do. And someone asked the weight of the system really late on. Our preheat system is 1.5 pounds is the added weight to the aircraft engine. So usually a weight and balance isn't an issue that you have to deal with.
Okay, I do have one more question here. What would be the coldest temperature to fly a Cessna 172 in the winter? I mean, that's written in the pilot operating handbook. If you're renting an aircraft, I think the flight clubs have their own set of guidance there too. It's usually way more conservative than what's in the pilot operating handbook. But Cynthia, Doug, any comments on that one?
Well, you know, we have operators that don't see warmer temperatures than -30 sometimes. But you have to refer to the POH, and if not, then you have to do the required preheating. And then you have to also determine, as the question about cycling your prop governor and such, you know, once you unplug from the preheat system, now you're up in the air. And there's a lot of things that you have to consider as a pilot when you're flying in that temperature.
Yeah, I would say the same. You have to look at your POH for the recommended temperatures, but I think you also have to consider your own skill levels and comfort levels. Just because you can go flying when it's -35, maybe you don't want to. I know I certainly don't enjoy that. That's just uncomfortable and cold. So it is a matter of following your POH, but also knowing your limits and setting personal limits for yourself, I would say.
Okay. That's pretty much all the questions that that I could see here that had to do with this presentation. I am getting a lot of great comments. Thank you so much, Cynthia, for the presentation. Thank you so much, Doug, again for a great presentation. They're always very welcomed. We did host a seminar in the late early spring, I believe, last year on surviving the, well, we didn't call it crash, but we called it something nicer than that. And we talked a lot about survival gear and what you should bring in case of a non-planned landing. That's what we called it, non-planned landing. So if you want to review that, it's still available on our website. If you're a COPA member, it's in the members only section. So there was a question there about what kind of survival gear you should bring. I do suggest reviewing that seminar because we go into quite a bit of detail as to what it is that you should bring. All of the other questions we will have answered. I promise you. Give us about a week and a half to get that done. Wishing everybody a very safe, a very happy holiday season. Happy Hanukkah to those who celebrate Hanukkah. Merry Christmas to those who celebrate Christmas. And happy holidays to those who don't celebrate either, but want to enjoy the festive season anyway. It's been a pleasure really taking care of all of this for my members this year. We've got a great team. We're going to do a lot more for you in the new year. We're really trying to encourage COPA flights to participate and give these seminars on our behalf as well. So lots coming up next year. Just want to take this opportunity to say happy holidays to you, Doug, and thank you for being with us, Cynthia. And any closing remarks from you, Doug or Cynthia?
Great job.
No, I just wanted to say thanks everyone for attending today. I hope you found it useful and informative.
All right. Have a great rest of your weekend, and thanks for spending this Saturday with us. Bye, everyone.